worship our King. Come, let us bow at His feet. He has done great things. See what our Savior has done. See how His love overcomes. He has done great things. He has done great things. Oh, hero of heaven, you conquered the grave. You free every captive and break every chain. Oh God, you have done great things. We dance in your freedom, awake and alive. Oh Jesus, our Savior, your name lifted high. Oh God, you have done great things. You've been faithful through every storm. You've been faithful forevermore. You have done great things, and I know you will do it again. For your promise is yes and amen. You will do great things. Yes, you will do great things. Oh, hero of heaven, you conquered the grave. Oh, you free every captive, you break every chain. Oh God, you have done great things. We dance in your freedom, awake and alive. Oh Jesus, our Savior, your name lifted high. Oh God, you have done great things. God, above it all, hallelujah. God, unshakable, hallelujah. You have done great things. Hallelujah, God, above it all, hallelujah. God, unshakable, hallelujah. You have done great things. You've done great things. Oh, hero of heaven, you conquered the grave. Yeah, you free every captive and break every chain. Oh God, you have done great things. We dance in your freedom, awake and alive. Oh Jesus, our Savior, your name lifted high. Oh God, you have done great things. You're the hero of heaven, you conquered the grave. Yeah, you free every captive, you break every chain. Oh God, you have done great things. We dance in your freedom, we're awake and alive. Oh Jesus, our Savior, your name lifted high. Oh God, you have done great things.
In your hand is the life of every creature, the breath of all mankind, and you began. Your promises are written in creation. Oh, everywhere I look, I see your plan. Even the rocks cry out, so I'll cry.
you'll find me singing worthy, worthy is the Lamb.
So
Enter in to the song of the ages, the one who was and is to come. There'll be no end to the song without beginning, the sound of saints and angels round the throne. Even the rocks cry out, so I'll cry out. Heaven and earth will sing, so I'll sing. Even the rocks cry out, so I'll cry out. Heaven and earth will sing, so I'll sing. Holy, 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 Lord God Almighty. You'll find me singing worthy, worthy is the Lamb.
I won't stop singing, I won't stop singing. These lungs were made to sing your praise. The heavens roaring, the earth resounding, as all creation sings your praise. I
Won't stop singing, no, I won't stop singing. These lungs were made to sing your praise. The heavens roaring, oh, the earth resounding, as all creation sings your praise. I won't stop singing, no, I won't stop singing. These arms were made to sing your praise. The heavens roaring, the earth resounding, as all creation sings your praise. You're holy, 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 Lord God Almighty. You'll find me singing worthy, worthy is the Lamb. You're holy, 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 Lord God Almighty. You'll find me singing And we're just so thankful. All the earth praises your name, and we are just so blessed to be able to be here tonight to listen to another testimony of how creation just sings your praise and how glorified you are. Even if we weren't able to sing or say anything or speak, Lord, the rocks would cry out and praise your holy name. They do. They continually do that. The heavens, they declare the glory of God. And so, Lord, we are just so thankful for the knowledge that you have given to us. Lord, we pray that we wouldn't take it for granted, but that we would walk in it as it affects the way that we live, the way that we think, the way that we love the people around us, the things that we say. Lord, we pray that you would be glorified, for you are a holy God above all things. And we exalt you this evening by even being in this place to listen to your word being declared, to listen to the glory of what you have done in the world around us. Lord, we pray that you would be lifted high and glorified, and we pray this in Jesus' name. Amen.
Right, you may be seated. Real quickly. So, we had a pastor's conference in Castle Rock about a month and a half ago, and that was the first time I had met Dr. Jason Lisle, and he was the main speaker at both evening services, and it was awesome. And we asked him if he wanted to come out here, and he was more than happy to come out, and so we are so blessed to have him with us tonight. Keeping along the same theme of our summer apologetic series, the last 2 Wednesdays, we had Dave and Mary Jo Nutting with Alpha and Omega Institute here. They did an amazing job. Dave's here. Thank you, Dave, once again. And tonight, Dr. Jason Lisle will take us into the stratosphere. I don't know how far. I'll let him. I'm not going to say anything because I'll butcher it all. I mean, this guy's got knowledge up to here. So anyway, let me just introduce Dr. Jason Lisle. Let's give him a warm welcome.
All right. Okay, well, it's good to be with you this evening, and I get to talk about my specialty field of astronomy and how it declares God's glory. And that's important because we live in an age where the Bible is under attack like never before. And if you think about it, science has been used incorrectly, I believe, to try and persuade people that the Bible's not true. Because let's face it, if you pick up a typical science textbook, you're going to get some good information, but you're also going to get some stories about the past. And those stories are not always compatible with what the Bible says, which means those stories are wrong. And they're not really science, right? When you talk about what happened in the distant past, that's history. It's not science. Science is about what's testable and repeatable in the present in terms of operational science, the kind that makes computers work and puts people on the moon and so on. And so, as my specialty field, I want to give you some information that will, I think, help you in terms of conversation starters, okay? Because a lot of times people have this misimpression that the Bible's been disproved by science. Nothing could be further from the truth. And when you understand the science, you'll find the Bible really is true. It really does mean what it says. I know there are some poetic sections of Scripture. Genesis is not one of them, okay? It's history. It's recording what God did. And so I think this will be helpful to you as we look at our society and we see people rejecting God's law, and we see the consequences of that in society. It's because, they would use evolution and Big Bang and things like that as intellectual justifications for rejecting the Bible and therefore the law and the gospel that follows from that. So we want people to be saved, and in order to do that, it's helpful to help them overcome that misconception that the Bible's somehow anti-science. And we're just going to talk about one field of science tonight, and that's just astronomy, and we won't talk about everything there is to know about astronomy because there's quite a bit. But I want to show you how the secrets of the cosmos confirm what the Bible teaches. In 5 areas, we'll see how the glory of God is revealed in His creation in the universe. The universe does declare God's glory. The Bible's right about that. We're going to see that the Bible is right when it speaks to the basics of astronomy, things you would learn in any freshman level astronomy class. The Bible does have some things to say about astronomy. And when it does, it's right. We'll talk about the age of the universe. We'll see the Bible is right when it speaks to that issue, and the Bible does speak to that issue. We'll see that the Bible is right when it addresses the uniqueness of Earth. Earth is not just another planet out there. It's very special in God's plan, and we'll see that the science confirms what the Bible teaches there. And then we'll take a look at the starlight issue and talk about how did God get the light from those galaxies to the Earth in the biblical timescale. And so let's jump right in and see in our first category that the Bible is right when it speaks about God's glory being revealed in the universe. The Bible says in Psalm 19:1, "The heavens declare the glory of God, and the skies proclaim the work of his hands." And that's certainly true. And I think there are a number of ways that the universe does that it declares God's glory. And I'm just going to stick with two tonight, and that is the size and the beauty of the cosmos are consistent with the mind of God, not chance. I think the majority of people who believe in, that the universe is just a cosmic accident, Big Bang that happened billions of years ago, and life is an accident, they tend to not know a lot about the subjects, because I have to tell you, the universe is amazingly well designed, and it is beautiful, and it is big. The beauty of the universe, you don't have to be a PhD astrophysicist to appreciate that. You can go outside at night and look up, and it's amazing. It's beautiful. And we live in a wonderful age where we have telescopes now that can zoom out into space, and it just gets more glorious the deeper you zoom into it. So just like God himself, God has built that aspect of himself into his creation. The size of the universe is a little harder to get. And I dare say none of us really, we can put a number to it, at least as far out as we can look with current telescopes. We can put a number to that thanks to scientific notation, which allows us to express enormous numbers in a very small space. But I don't think we can really picture it. But what we can do is compare certain things to other things and kind of give you just a feel for the immensity of the universe that God has created. It's not a cosmic accident. It is amazingly well designed. And we'll start with the moon. The moon is about the size of the United States. If you were to put the United States at the same distance as the moon, it would cover about the same area. If it looks much smaller, that's because it's 240,000 miles away. So there you go. And this is a mosaic image of the moon where they've taken a bunch of very high resolution images and stapled them together. And so that's why it looks a little bit odd, but pretty amazing. And it's enjoyable to see the moon in a small telescope. And I love showing other people the moon in a small telescope because it's cool. And the reaction they usually get is, wow. And then sometimes they'll say, can you see the flag that the astronauts plant? No, you can't. That's the size of the United States, okay? You're not going to be able to see the flag. You can see craters that are several miles across, perhaps, but the flag's pretty small. That being said, we do have a spacecraft that's orbiting the moon and taking high-resolution pictures of the surface, the Lunar Reconnaissance Orbiter, and we've mapped the moon in such detail that we can actually see with that spacecraft where the Apollo astronauts landed. Pretty neat. And we're going to do that. We're going to zoom in here on Mare Tranquillitatis. This is where the Apollo 11 mission landed. And you can see the lower section of the spacecraft is still there. Remember when they, that spider-like looking structure, the LEM? And when they took off, they launched only the top portion of the LEM to save fuel. So we leave junk everywhere we go, and you can see that there. And some other instruments that they left on the surface. And then there's that dark line that you see that extends over to that crater and back. That's the footprints of the astronaut as they walked over to that crater and back. So 50-year-old footprints, pretty amazing. And they're not going to go anywhere because the moon has no air. There's no atmosphere at all to stir up the dust. There's no maid service. So those footprints are going to be there for a long time. Pretty amazing. So there you go. And the scale of the cosmos really is as amazing as its beauty. So here's the moon. And this is when it looks best in a telescope, when it's in that first quarter phase, when it's illuminated right down the middle, because then you can see the shadows of the craters. And it's hard to describe, but when you see it in a telescope, your brain immediately recognizes it as a sphere because of the way the light, the light in the shadows, the way that falls on the craters. Your brain immediately figures out that spherical shape, which I think is amazing because it shows not only God's design of the moon, but God's design of the human mind. You've got a computer and you made a meat that can immediately take that shape and calculate its three-dimensional nature. That's awesome. That is really awesome. Here's the moon compared to the Earth. Pretty nice. You might say, we got a pretty big planet there, quite a bit bigger than the moon. And it is. We got a big planet. If you've ever driven through Kansas, we got a big planet. Right? Yeah. And it is. It is. And it's beautiful. And what a privilege that we live in a time where we now have pictures of the Earth from space. That's something that our ancestors only could have imagined. We get to see it. That's amazing. And even Captain Kirk got to go up. What was last year? Captain Kirk got to go up for real and see the Earth from space. So anybody can do it as long as you're a multimillionaire. Okay. The Earth's small compared to Saturn, though. Now, it's interesting because Saturn, when you look at it in a telescope, it looks like it's about that big. It's beautiful. You can see the rings. It's gorgeous. But it looks so small. Astronomy is quite a lesson in perspective because the true scale of Saturn is 9 Earths across, and that's just the planet. The rings extend out further into space. Amazing. And the reason it looks that big is because it's a billion miles away. Yeah. The moon, 240,000 miles away. That I can kind of get my mind around. If you got a really good car, it might have 240,000 miles on it. You could have driven to the moon, but probably not back. Saturn's a billion miles away. You're not going to make that trip. You're not going to make that trip. Saturn's small compared to the sun, though. The sun is about 100 Earths across. It's amazing. It's basically made of hydrogen gas, and its own gravity holds it together. Yes, gas has gravity. If you get enough of it, it'll hold itself together in a spherical shape. The sun rotates, and it's that hydrogen gas that's fusing into helium in the core that provides the power for the sun. And it's an astonishingly efficient power source because the sun actually expels more energy in 1 second than 1 billion cities on Earth could use in an entire year. It's really astonishing. And you say, well, why would God waste all that energy? God has unlimited power. It's not a problem for him. And see, the thing is, the sun's just one star. Yeah, there's little pinpricks of light you see in the night sky. Those are suns. They're like our sun, and in some cases. The sun's a main sequence star, which means main sequence means it obeys a rule that if you know the mass of the star, that will determine all of its other properties, its brightness, its color, its surface temperature, and so on. The sun obeys that rule. Most stars do, some don't, and the ones that don't are bigger. So lots of stars. Most stars are smaller than the sun. These are red dwarfs, and they are everywhere. So you might think, well, we got a big star, and it's bigger than average in terms of number. If you just count the nearest 100 stars, the sun would be in the higher ranks there. But there are stars that are a lot bigger than the sun, like Mintaka, for example, which is one of the stars of Orion's belt that you see in the winter sky. It's a blue supergiant, so it's very bright and very, very big. Canopus, yeah, even bigger than Mintaka. So again, the sun down there for scale, pretty amazing. And then, of course, you have Antares, which is over 600 suns across. And so it's just amazing. The amount of mass that's in that is just staggering. And the size. If you'd put that where the sun is, we'd be inside it. That's something to think about. Now, some stars are kind of like the sun. They're by themselves. Some stars come in binary pairs, rotating, orbiting around other stars. And then some stars come in clusters. And this is what we call a globular cluster. There's 2 types of clusters in the universe, open and globular. This is a globular. Opens have kind of a random shape, a few thousand stars. Globulars are spherical and have probably about 100,000 stars each. Of course, we can only estimate it. And the Bible, of course, says that God calls them all by their names. God has a name for each and every one of those stars. And that's just one cluster. Pretty amazing. I love looking at these, and you can see these in a small telescope. If the telescope's bigger than 8 inches in diameter, you can see the individual stars in it, and it is glorious. And I have to say, there's something magic about seeing it with your own eyes. The computer just doesn't quite capture it. Anyway, some of my favorite objects are not stars at all. They're nebulae. That's the plural. Nebula means cloud, but they're different from Earth clouds, which are made of water in suspension. These are made of hydrogen gas. And if there are stars nearby, they'll heat up that gas and cause it to glow, and you get these beautiful and vivid colors in many different nebulae. This is the Tarantula Nebula. And you can see there's actually a star cluster in the lower right. So sometimes you get 2 for the price of 1, and that's always kind of nice when you can see both of those beautiful objects. The scale of this artwork is amazing because our solar system would not show up on that image. That's how big it is. God paints beautiful artwork, and he does it on an enormous canvas. Some nebulae are relatively small, but by cosmic standards. They're only about the size of, say, our solar system, which is pretty big, but small compared to the rest of the cosmos. That's a planetary nebula, and it has nothing to do with planets. It's just some of them look round and like an out-of-focus planet, but they have nothing to do with planets. A planetary nebula is where you have a star in the middle that's ejecting gas, making the nebula. And so this changes a little bit century by century as that gas expands out into space. And a lot of times it forms kind of a two-lobe structure. We think there's material accreting around the disk of the star, and that funnels the gas out the north and south pole. So you have that bipolar structure. And then some of them are round, and it could be the round ones are also bipolar, but maybe we're looking right down the barrel. We don't really know. We can't get another angle on it, so because we're here and we're not going anywhere. So there you go. One of my favorites is the Ring Nebula because it's the first that I learned how to find, and you can see this in a small telescope, not too far away from the star Vega in the summer sky. Now's a good time to see it, actually. And I have a book out there that'll show you how to find these things if you're interested in that. So this is where the star now has collapsed in on itself. It's a white dwarf, and it left this lovely parting gift. That's basically the outer portions of the star that are expanding away. Very gentle fashion. Beautiful. And it's fun to see that. Now, normally you can't see the color as vividly because you're using primarily the rods when you look at something faint. So it looks kind of like a gray version of that, but it's very pretty. And it's so weird to see this little smoke ring hanging there in space, It's just weird to see this little cosmic Cheerio suspended on nothing. And there it is. Now, all these things we talked about, all these stars and star clusters and nebulae are part of a much larger structure called a galaxy. That's a galaxy. That's about 100 billion stars. So many that it's difficult to pick out any individual one. And so they kind of swirl together like that. That's a spiral galaxy. All kinds of galaxies out in the universe. There are galaxies of tremendous beauty. There are galaxies of tremendous ugliness too. So there you go. There are galaxies with large mysterious arrows next to them. You'll see that in all the textbooks. There it is. And they're always pointing to something interesting like that supernova. That bright spot there is one star in that galaxy that exploded and briefly became as bright as the rest of the galaxy for a few months. The explosion takes time because it's big. And that's one I got to see, so that's kind of neat. There are galaxies that have rings of stars surrounding. That's pretty neat. There are galaxies that look like flying saucers. That's a real galaxy. They call that the Sombrero Galaxy. It's part of the Virgo supercluster, visible in late spring. You probably still see it this time of year. And it's got that dark dust lane that blocks the light from the stars behind it. But that glow, that's 100 billion stars, folks. Just amazing, the power that when God spoke these into existence. Galaxies in the process of collision. Actually, the stars would pass right by each other because the distance between stars is enormous compared to the size of stars. If you take our entire solar system out to the orbit of Neptune and put it in a cube like that, how many cubes to the next star? 4,278 to the next nearest star. There's a lot of empty space out there. We find now that galaxies come in clusters too. These are not individual stars. Each one of those little fuzzy things you see there, that's a galaxy. Each one of those could have 100 billion stars in it. Some more, some less. Some of them get up to 1 trillion. And as we go even deeper into space, you find galaxies upon galaxies upon galaxies. This is not a star field, this is a galaxy field. You mean those tiny little blips in the background? Those are galaxies at tremendous distances. This was taken by the Hubble spacecraft, the Hubble Deep Field. We're expecting probably just next month some images from the James Webb. I don't know if they've done a deep field like this, but eventually we'll be able to go even deeper thanks to the Webb telescope. I like the way the Bible describes the creation of all these hundreds of billions of galaxies with hundreds of billions of stars. He made the stars also. That's it. As if it was so easy for God to speak those into existence. And of course it was, because he's God. He has unlimited power. And if you think about it, he did all that. He did it in 6 days. Everything we're seeing here, he did in one day, day 4. 5 of the 6 creation days, God's working on the earth, making it right for life. He takes one day, day 4, makes everything else. The sun, moon, the stars also. Pretty amazing. Almost like an afterthought. You know what would go really good with an earth? How about 100 billion galaxies? And God can do that because he has unlimited power. People say, why did he make it so big? Why did he make the universe so big? Now, I don't know the answer to that, but if it was to impress me, he succeeded. He succeeded. The heavens do declare God's glory. They are spectacular. Well, we want to move on, though. What about the basics of astronomy? Things you'd learn in an astronomy class. People have said, well, the Bible's not an astronomy textbook. And that's true, because astronomy textbooks, we have to update them every few years when we learn that we got some things wrong. God never got anything wrong. The Bible is primarily a history book, but it's inspired by God. So when it touches on astronomy, it's right. And the Bible does have some things to say about astronomy. And we'd have to agree today in your college freshman level astronomy class, yep, the Bible was right about that. But the interesting thing is, there were times when people would have said the Bible's wrong about that. Let me give you some examples here. The spherical nature of the earth. The Bible talks about the earth being round in multiple places. The circle of the earth in Isaiah 40:22, you think, well, that could be a flat disk. But Job 26:10, I don't think you can interpret that any other way than being spherical. It says that God inscribes a circle on the face of the waters at the boundary between light and darkness. Now, that boundary between light and darkness is what astronomers call the terminator. That's where sunrise and sunset are occurring. And the only shape in which that will form a circle is a sphere. It's the only one in which it'll, no matter how you rotate it, it's always always a circular terminator. I think that's very interesting because if you consult most astronomy textbooks, most of them will credit Pythagoras with being the first to come up with the idea that the earth might be round. Aristotle is usually the first to consider to prove that the world is round from shadows of eclipses and things like that. It's not hard to do that, actually. I've got some articles on that on our website. But Pythagoras is 500s BC, Aristotle's 300s BC, Isaiah 700 BC, Job 2000 BC. As far as I know, the earliest reference to a round earth is in the Bible, in Job. Isn't that interesting? Which means at that time, the secularists would not have agreed with that. The secular experts did not think the world was round at the time of Job. It wasn't until around the 500s BC that the Greeks started considering, maybe the Bible's right about that. And of course it is. By the way, the idea that Christopher Columbus was the first to propose the earth might be round and was out to prove it is a myth. That's not the case. Everybody knew the world was round at the time of Columbus. He just thought it'd be faster to go that way, which it turns out it isn't. But I'm glad he made the trip. Earth is suspended in space. The Bible says that God hangs the earth upon nothing, a beautiful poetic description of the nature of gravity. The earth is suspended on nothing, isn't it? That's amazing. We have pictures of it now that illustrate that. And again, the experts of the day would have said, well, that can't be right, because, again, Job 2000 BC. Early Greek experts taught that the earth was a flat disk and floated in water. And wouldn't that make more sense? Because we've seen things float in water, right? We understand buoyancy. That we can see, that we can picture. The Bible can't be right about that, except it is. And we got the pictures today that illustrate that. The experts of the day were wrong. The Bible was right. Today we'd have to all admit that. Expansion of the universe. God stretches out the heavens as a curtain, spreads them out as a tent to dwell in, indicating that God has apparently increased the size of the universe since it was first spoken into existence. And that's interesting because, again, that's Isaiah 40:22. It's the same verse that talks about the circle of the earth, interestingly. And that's around 700 BC is Isaiah. It wasn't until the 1920s that secular scientists came and realized, you know what, the universe appears to be expanding. Isn't that fascinating? And it's really remarkable, too, because the way that this expansion was discovered, it's tricky to do it. You need modern technology. You need a spectroscope, and you need a telescope. Telescope wasn't invented until 1608, and the spectroscope, a couple centuries after that. You need those two devices to be able to measure redshifts of galaxies, which shows their recessional motion away from each other and from us. So it's as if the entire universe is getting bigger. Okay, it's not a catastrophic rate, which is why you don't notice it, but galaxies get a little further away from other galaxies every day. And it's amazing to me, again, because it takes modern technology to discover that by scientific means. How did the Hebrews know that? It's almost as if they had some kind of divine insight into this issue. Of course they did. They did. By the way, some people have said, well, does this mean there was a Big Bang? Because the secularists say, see, if you run that backwards, then that means the galaxies were closer in the past. Okay? If you run it back 13.8 billion years, they go back to a point. So doesn't this prove that, that the universe started in a Big Bang 13.8 billion years ago since it's expanding? The answer is no. Some of you are expanding. That doesn't mean you exploded into existence 13.8 billion years ago, right? Which means you're a little bigger than you used to be. Apparently, God created the universe with size and has stretched it out since then. There's no reason to extrapolate back to a point. That doesn't make any sense to me. It's just they can't go back further than that, so they say, well, that must be the beginning then. No, God made the universe with size because the earth's already in it when he made it. So it wasn't a Big Bang. Well, does this at least support the Big Bang? Because didn't the Big Bang predict that there should be expansion of the universe? And the answer is no. The expansion of the universe was discovered in the 1920s. The Big Bang theory, the idea that the universe comes from a point, was 1931. The inventor of the Big Bang, Lemaitre, he already knew about expansion of the universe, and he was trying to come up with a natural explanation for it, one that did not invoke God. So it's not a prediction of the Big Bang. It is a prediction of the Bible, because the Bible indicated that before it was discovered by observational means. Conservation of energy and mass. This one's a little more abstract, but I believe it's biblical. The energy is the amount of sort of motion and things like that, and mass, how heavy something is. And Einstein tells us energy and mass really are the same thing. They're just measured in two different ways. So basically, conservation of energy means you can't change the amount of mass or energy in the universe. You can convert one type of energy to another. You can change one type of mass to another, but you can't get rid of it and you can't make it. Okay? And so if you have a box with a certain amount of mass and energy, if it's totally tight and doesn't release or take in any energy, whatever was in there to begin with will remain that way. And we would expect that on the basis of Scripture because God is no longer creating. So we'd not expect new stuff to come into existence, right? Because all things were made by him and God ended his work on the seventh day. If something new were to pop into existence, it would mean that God either has not ended his work on the seventh day, which would violate Genesis 2:2, or it would mean that things can come into existence apart from God's creation, which cannot be by John 1:3. Okay? Furthermore, things are going to not cease to exist because God upholds what he's made. He upholds all things by the word of his power, and by him or in him all things consist or hold together. And so God continues to uphold the material that he created. He does allow us to change its form, but not to make. We can't create. We can reshape things that God created, but we can't create anything, really, in terms of physical. Now, does this preclude a creative miracle? No, God can do what he wants. That's not a problem. But basically, he's done creating until the new heavens and the new earth, in terms of new material, new physical atoms and things like that. So these two principles together, energy doesn't come into existence, energy doesn't cease to exist. Conservation of energy or conservation of mass. And it's kind of hard to pin down when these were discovered by scientific means. Usually James Joule is credited with the discovery of conservation of energy, at least, by colliding particles and seeing how they, the energy before and after all was matched. But you know what? He was motivated by Scripture too, because he pointed out that it would, something to the effect, I'm paraphrasing, but something to the effect that it makes sense that the energy would be constant because God's done creating. So, pretty neat. Uncountable numbers of stars. The Bible describes Abraham's descendants as the stars of heaven and as the sand which is upon the seashore. Pretty good analogy for a humanly uncountable number. And another section says that, which cannot be numbered for multitude. So it's a number that human beings cannot count. And that's a pretty good analogy. Pretty good analogy. It might not have seemed such a great analogy when it was first written because the number of stars you can see with the naked eye is somewhere between 3,000 and, if you have superb vision, maybe 10,000, assuming you stayed up all night as the planet rotates and so on. Now that's a lot of stars, but you could count to 10,000. You could do that. It would take a while. It'd be tedious, but you could do it. But then in 1608, a telescope was invented. In 1609, Galileo built his own. In 1610, he got a really good one, started looking up. He started looking at the Milky Way, that cloudy band you see in the summer sky. Oh, that's made up of hundreds of billions of stars. And you can't count to 100 billion in your lifetime. You can't do it. Not that you'd want to, but you can. So it is a humanly uncountable number. As a matter of just a historical quirk, there was a time when most astronomers believed there were exactly 1,022 stars, something like that. Why? Because the Greek historian had cataloged 1,022 stars, and there was a philosophy that everything worth knowing had been discovered by the Greeks. Now, Ptolemy never claimed that his list was exhaustive, but that was the assumption, is that, well, if there were more, he would have found them, despite the fact you can see more than that. So it really shows you how a bad philosophy can cause you to misinterpret data, whereas a correct philosophy, a biblical worldview, can help you interpret data correctly. Now, do we get the point? Have we learned the lesson of history? That's what I want to know. Because in the past, whenever the experts of the day have disagreed with the Bible has always turned out to be right. Right? I mean, there was a time when the Bible said Earth's round, right? Because the circular terminator, and the secularists said that can't be right. There was a time when the Bible says the Earth floats in space. There was a time when the secularists said no, it doesn't. And the experts were what we call wrong. And the Bible was right. Have we learned that lesson? Have we learned today that you're not going to outsmart God? If something in the Bible, properly interpreted, I understand that. If something the Bible affirms, it's true. Not everyone's learned that lesson, sadly, because there are some places today where the secular scientists say, yes, but the Bible's wrong about this. We have to admit it got the shape of the earth right and things like that, but it's totally wrong about, and one of those issues is age, the age of the universe. But the Bible's right about that, and what I want to show you is that when you really look at the science, it actually lines up with the biblical time scale. The Bible does teach a universe that's a few thousand years old, something like 6,000 years. Can't put an exact date on it, but it's not going to be millions, that's for sure, or let alone billions. And the earth is made, heaven and earth and all that's in them, are made in 6 days, according to Exodus 20, verse 11. And in fact, most of the universe beyond earth is made on day 4. It's made on that first Wednesday, and that's kind of neat. So most of the universe is 3 days younger than the earth. It's not billions of years older. So in any case, and from adding up, those genealogies you'll have to read before you go to bed, and so beget so-and-so, and they beget so-and-so. You can calculate the time spans between certain events, and there's certain decrees that are issued, and so on up to the Messiah. It's about 6,000 years, something like that. And I got to tell you, that's not popular in academia to believe that God created the universe 6,000 years ago. But if you want to be popular, Christianity is not for you. Let's put it that way. But I'd rather be saved. That's a much better thing. In any case, the Bible's clear about the age of the universe. It really is. And I know people try to twist the scriptures to get around that. You really can't. The word day, yom, it really means day in that context. It can't mean time in that context, and so on. But you don't need to. The science lines up with that. And there are a lot of processes in the universe that show that it's much younger than the billions of years that the secularists need. You understand the secularists will never give up billions of years because even they recognize evolution can't happen in 6,000 years, right? They need that for evolution, and they need evolution to reject, to reject a creator, you see. So it's a chain in the step in the chain. So one process that shows that the solar system cannot be billions of years old, because the secularists say the solar system is about 4.5 billion years old. But it can't be because of the excess heat of the giant planets like Jupiter, for example. Jupiter gives off twice as much energy as it gets from the sun. Okay, it gets 1 unit, gives away 2. Gets 1 unit, spends away 2. It's kind of like our federal government, okay? And like our federal government, it can't do that forever because eventually runs out of heat, runs out of energy. It's kind of like a potato that you just nuked it in the microwave, you take it out. You can feel the heat coming off of it, right? It radiates heat into space. That's a property of thermodynamics. If you come back 2 hours later, what's cold then, isn't it? It's radiated away all its heat. And so it can't continue to do that indefinitely. Now Jupiter is a much bigger potato, and so it can do that for 6,000 years, and it's still, because it's 10 times the size of the Earth, so it can do that for a while. But it can't do it for billions of years, and that is a problem in the secular worldview. Neptune gives off 2.6 to 2.7 times as much energy as it receives from the sun every second of every day since creation. Why does it still have that internal heat? Why does it have that? Because it's not billions of years old. That's the answer. I have read technical journals where people have tried to answer that, and usually have to come up with 4 different explanations for the outer planets, because Uranus doesn't do that. Uranus is different. So anyway, it's just kind of wild. The magnetic field of the Earth. The Earth, you might know, has a magnetic field that's caused by electrical current in the core, and that acts like a shield that protects us from harmful cosmic radiation, some of which is from the sun, some from other stars, and so on. It acts like a shield around the Earth, an invisible shield, pretty neat. Occasionally it gets disturbed, and that's what causes northern lights. But that energy is decreasing because electrical current encounters resistance, and it decays away. And we've been able to measure the decay of the Earth's magnetic field since about the 1830s or so. And it's decaying. We can measure that. And it appears to be an exponential decay, which is what we'd expect. Exponential means as you go back in time, it gets really steep, right? And it never quite goes to zero, but it gets, shallower and shallower. That's an exponential decay. We think that during the flood year, that God used plate tectonics to both cause and end the flood, and that we think that disrupted the magnetic field, caused it to flip rapidly. In any case, other than that, it's just been decaying away, and as we would expect. And you run the equation backwards, 6,000 years ago at creation, the magnetic field would have been about 20 times the strength that it is today. That's pretty neat, because you'd have increased protection from cosmic rays. Cosmic rays are bad. Cosmic rays can cause things like cancer and so on. So That would have been kind of nice back then, and your compass would work even better back at creation. But if you go back 60,000 years, it's an exponential decay. So it gets really big. In fact, it gets so big that it'd be stronger than the magnetic field of a neutron star, which is enough to rip the atoms of your body apart. You don't want that. That's bad. So, and we're not talking millions of years, we're talking 60,000 years. That's a pretty tight constraint on the age of the Earth. It can't be anywhere near that old, or life would not be possible. It's not just Earth. Some of the other planets of the solar system. Jupiter has a whopping big magnetic field. It would be bigger than the sun if you could see it. It's very powerful. It's too strong for life. It could induce harmful currents in you and so on. Why does it still have that magnetic field? Magnetic fields decay with time. They do. They run down. Batteries run down, right? A magnetic field is basically it's like a battery. It runs down over time. Jupiter's a big battery. It can last a while, but it can't, 4.5 billion years. Why would it still have that magnetic field? Uranus and Neptune. This is the planet Uranus. It's tilted on its side, so it rotates this way. It rolls around the sun. Kind of neat. And then the magnetic field is not aligned with the rotation axis. So Uranus is just messed up on a number of levels. It really is. And the secularists were expecting that there would be really not much of a magnetic field left on Uranus because the planet's, in their view, 4.5 billion years old. And it's smaller than Jupiter, so it can't, smaller batteries don't last as long as the bigger ones, right? You know that. The little A cells don't last as long as those big old D cells that we used to use and don't really too much anymore. But in any case, a friend of mine, Dr. Russ Humphreys, who's a creation physicist, actually predicted the magnetic fields of Uranus and Neptune based on their biblical age of 6,000 years. He predicted that in 1984. And in 1986, Voyager 2 flew past Uranus, and Dr. Humphreys' predictions were right. The secularists were way off. Uranus does have a measurable magnetic field. In fact, that little spot that you see down there at the bottom, that's an aurora. That's northern lights on the planet Uranus. And those are caused by disturbances in the magnetic field. So the fact you can have aurora tells you it's got a substantial magnetic field. And likewise for Neptune as well. And again, Dr. Humphreys predicted those. He's got a model that calculates the strength of the magnetic field based on 6,000 years for all the planets and moons in the solar system, and it works. But the neat thing about Uranus and Neptune is they hadn't been measured when he proposed this model, and so it was a successful prediction. Pretty neat. By the way, the secularists, if you're wondering how they deal with this, they think that there must be some kind of recharging mechanism because they know that magnetic fields decay. So they say there must be some kind of dynamo that recharges it. But one of the requirements of that model is that the magnetic field axis should be aligned with the rotation axis. On Earth, they're not too far off. They're like 11 degrees apart or something. But on Uranus, they're not even remotely close, and likewise on Neptune. So that doesn't seem to work very well. Recession of the moon. The moon is actually moving away from the Earth due to tidal forces. You might know the moon causes tides, ocean tides, and the ocean tides get ahead of the moon because the Earth rotates faster than the moon orbits. Okay, and so what the tides do is they pull forward on the moon. And what happens when you pull forward on something in orbit, you give it energy and it moves out. It's a little bit counterintuitive, but if you've ever played with a gyroscope, you know that when things are spinning, they don't always behave the way you'd expect. But yeah, if the moon gets extra energy, it moves out. That's what the astronauts want to do. If they want to get into a higher orbit, they thrust forward, and that puts them into a higher orbit. So we'd expect that. We can measure it today because we left reflectors on the moon when the astronauts landed there, and we can bounce a laser off of it and time it and get the distance to a fraction of an inch. Pretty amazing. And the moon is receding away at about 1.5 inches every year. It's not a huge amount considering it's 240,000 miles away. So at creation, the moon would have been about 750 feet closer to the Earth than it is today. Not even a mile difference, right? But if you run it back billions of years, you got a problem. And you have to do the math right because as the moon is closer to the Earth in a hypothetical past, the ocean tides would be greater, wouldn't they? And that would cause a faster motion. So it actually speeds up as you go back in time. And if you do the math, the moon and Earth would be in the same place at the same time, 1.4 billion years in a hypothetical past. Now that's a problem because in the secular view, the Earth and moon system are supposed to be 4.5 billion years old. But you see, 1.4 is less than 4.5, right? Just want to make sure all the Common Core folks understand. Okay. So that's a problem. So comets are made up of icy material, and they can't last billions of years. Comets are made of kind of ice and dirt, and they orbit the sun in elliptical paths. They go far out where the ice remains frozen, and they swing in and then whiplash back out. When they come close to the sun, you're thinking ice close to the sun, that can't be good, and you'd be right. The sun causes that ice to basically sublimate, to vaporize, and that's what forms a comet's tail. That's the material that's being ablated away from the surface of the comet. Every time you see a comet, it's getting smaller, it's losing mass. That's what the tail is. Okay? And we can calculate the rate at which the material's being depleted because we can see it, we can measure that, at least estimate it. And we know how big a comet nucleus is. They're typically only a few miles across. The largest one we've ever seen, Hale-Bopp, was like 40 miles across. So they're not, planet-sized or anything. And we calculate a typical comet could last no more than about 100,000 years before it completely runs out of material. But we still have lots of comets, right? And that suggests to me the solar system's not that old. And again, there's always a rescuing device, right? The secularists are always proposing a hypothesis, a speculation to protect their worldview from what appears to be evidence to the contrary. And in this case, they'll say, well, there must be a comet generator that makes new ones, right? Which they call the Oort cloud. So if you've ever heard of the Oort cloud, that is an invention to try and save the 4.5 billion years from the evidence that we still have comets, which can't last that long. So I won't go into details on that, but it's kind of interesting. Spiral galaxies. Not all galaxies are spiral, but a lot of them are. We live in a spiral galaxy. And spiral galaxies rotate differentially, which means the inner portions rotate faster than the outer portions. Think what that would do to the structure over time. If the inside's going fast and the outside's going slow, what does that do? It's going to get twisted tighter and tighter, isn't it? That spiral structure would have to get tighter every rotation. And in the secular view, these galaxies are supposed to be 10 billion years old. But I've actually run some computer simulations to see how fast does it take them to wrap up beyond recognition. Less than 100 million years. You don't see the spiral structure anymore. It's gone. It's wrapped so tight, it's like an old-fashioned phonograph record. You can't make out the individual grooves anymore. And so galaxies aren't anywhere near 10 billion years old. That would just be one evidence consistent with that. You might notice the galaxy arms are bluish. That's accurate. They have a higher proportion of blue stars. And blue stars themselves are a problem for the billions of years because they can't last that long. Blue stars are the most massive stars in the universe. They have the most material available, but they're also the most luminous. They expend their energy. Some of them are over 1,000 times brighter than the sun in terms of the energy they're giving off. So they use up their fuel at a ridiculous rate. So they're kind of like the SUV of the star world. They have a big gas tank, but they get really bad gas mileage. So they can't go very far in time. And in fact, most of them can't last like 1 million years even. But the universe is supposed to be 13.8 billion years old. And my secular colleagues, they won't even argue that. They know that blue stars can't be billions of years old. They won't bother to argue that. But they think that maybe new ones have formed recently. But no one's ever seen that. No one's ever seen a star form. And there are some physical problems getting it to form because gas tends to expand. It doesn't normally want to collapse in on itself. Now, once you have a star, it's a gravity will hold it together. But the force of gravity in a nebula is very meager compared to the outward force of gas pressure. So that's an issue. So all of these are just indications that the universe is much younger than the secularists would like you to believe. And they're just scientific evidence. That's what it is. That which confirms Scripture. The uniqueness of Earth is another issue where the secularists haven't quite caught up to the Bible because the Bible indicates that the Earth is special. It is unique. It's the planet God formed to be inhabited, right? Isaiah 45:18, God formed the earth. He didn't make it to be a waste place. He formed it to be inhabited. And indeed, the earth has all the right properties that are necessary for life on its surface, abundant liquid water and right distance from the sun to have the right temperature and the right luminosity and so on. And if you think about it too, the earth, again, is 3 days older than anything else in the universe because God made the earth on day 1. All the other luminaries, all the other stars and planets were made on day 4. By the way, the Hebrew word kokab, which for stars, that would include planets as well, other than the earth. Okay, so we use a slightly different classification scheme today. So the other planets, not designed for life. The moon, I'm glad God made it. It's cool. It's fun to look at. It serves life on Earth by stirring up the oceans, preventing them from stagnating. That's a nice feature. But it itself is not designed for life on its surface. The temperature between day and night, hundreds of degrees. There's no air on the moon, so you couldn't breathe. That would be an issue. There's no liquid water on the moon. There's nothing to eat on the moon. The astronauts, if you think about it, they had to bring a little bit of Earth with them. They had to bring some food from the Earth, some air from the Earth, and so on, water. in order to survive for as long as they did, and they wouldn't want to spend a whole lot of time there because the moon is often outside Earth's magnetic field. You don't get that protection from the cosmic rays, so that's going to be an issue if they ever want to set up kind of a base on the moon. They're going to have to figure out how to deal with that. One of the astronauts who walked on its surface referred to the moon as a magnificent desolation. I think it is. It has a beauty to it, but it's a desolate beauty. You don't see the life that is so rich here on Earth. Earth's neighbors, you got Venus on the left there, Mars on the right. Venus a little closer to the sun, Mars a little further away. They're Earth's nearest neighbors, planet-wise. They declare God's glory, not designed for life, however. There was a time when there was secular astronomers who thought maybe Venus might have all kinds of life on its surface. Maybe it might be a tropical world with all kinds of exotic creatures. And of course, they were free to speculate because Venus is permanently enshrouded in clouds. And so it's always nice, if you're an evolutionist, to be able to speculate, unfettered by inconvenient data. But, well, that was before they learned the surface temperature is 900 degrees Fahrenheit. Enough to melt lead. So, yeah, you don't want to go there. And by the way, the clouds are made up of sulfuric acid type compounds. There are just lots of ways to die on Venus. The surface pressure would crush you like a tin can because the atmosphere is like 100 times the atmospheric pressure of Earth. So it's just a question of which thing's going to kill you first, okay? People say, why would God make a planet like that with a toxic atmosphere and 900 degrees Fahrenheit? Well, you're not supposed to go there. He didn't make it a vacation spot, right? Those clouds that would kill you if you were there are highly reflective, and they make Venus the third brightest object in our sky. You got sun, moon, Venus. It's beautiful. Evening star, the morning star, maybe you've seen that. And then you got Mars. Now, Mars is a little better in that it would kill you slower. Okay, you're still going to die, but you might be able to take in the scenery for a few seconds before you suffocate. So there's that, because Mars has a very thin atmosphere of carbon dioxide, which you cannot breathe. Surface temperatures are rather chilly, and again, no liquid water on its surface as far as we know. There's evidence that it had water at one point, and perhaps at certain times still can, but in any case, it's not designed for life. It doesn't have that protective magnetic field that the Earth has. And so it's not designed for life. And it is really cold on Mars. So it's kind of like Goldilocks and the Three Bears. You got those ones too hot, that one too cold, that one just right. And of course it is. It's designed for life. That brings up the question, though, what about extraterrestrials? And I'll grant the Bible doesn't specifically say there's not extraterrestrial life, but I wouldn't really expect to find life on these other worlds out there because it's the earth that God formed to be inhabited, right? And it's the earth where God placed those special creatures that are made in His image. And if you got like Vulcans and Klingons out there, well, you got some theological issues you got to have to think through because they can't be saved, right? Because Christ became a man to die in our place on the cross. And it's because we're all of one blood, meaning we're all related, that Jesus counts for us on the cross. Okay, so if you're human, you're eligible for salvation because you're related to Jesus. He's your brother. But see, Lieutenant Worf, out of luck because he's not related to Jesus. He's a Klingon, and so he can't be saved. And so that's a bit of an issue. And what if Jesus went to the Klingon homeworld and died for them? The Bible says He died once for all, right? So again, there's some theological issues you're going to have to think through if you believe in extraterrestrial life. I don't think they'll find any. The secularists would love to find extraterrestrial life. Because it would justify their belief in evolution. The idea is Earth's just another planet where the chemistry happened to be right and life evolved from the slime. It probably happened elsewhere. Probably happened differently. And so, but the fact is, we haven't seen any evidence of that anywhere. We haven't seen it when we went to the moon, no life. Mars, no life. Every other object we visited, no life. And so I think the data is very consistent with what the Bible teaches, or at least what I would infer from Scripture. What about distant starlight? I want to spend some time on this because it's a challenging issue in terms of explaining it, really. But I want you to know we do have an answer for this. It's not a problem for a quote-unquote young universe, a universe that's thousands of years old, not billions. Here's the objection. This is the objection that some critics make. Well, we have these distant galaxies that are very, very far away, and based on how far away they are, it ought to take light billions of years to get from there to here, right? Because even though light's extremely fast, 186,000 miles per second, go around the Earth 7 times in 1 second, that's impressive. But those galaxies are so far away that even at that incredible speed, it would take billions of years for the light to get from there to here. And the light has gone from there to here because we can see him. So doesn't that prove that the universe is billions of years old? The answer is it doesn't, but the question is why. And so that's called the starlight issue, the starlight problem. And I do have to point out that, because some people will come up, have you thought of this? Yes, we've thought of that. There's a reason it doesn't work. Okay, so there are some solutions that have been proposed that some of them were kind of a neat idea, but they don't really work. I don't want to spend a lot of time on this because I want to get to what the answer is, but I just want to point it out. Some people have said, well, maybe the stars really aren't that far away. Look, there's good science that tells us the stars really are very distant. The calculations, the measurements by which we estimate distance to stars are not based on secular thinking. They're based on things like math and geometry, so that's good stuff. And frankly, even our own galaxy won't fit within 6,000 light years. So the universe is really big. That's not the issue. Some have suggested the speed of light was much faster in the past. Yeah, and I'm glad that was proposed, because sometimes secularists assume that rates are constant when they're not. That is an answer to some issues. Is, well, it'd take millions of years to form that canyon. Not if there was a worldwide flood, right? But in any case, we don't think that's the right answer for this issue, because the speed of light is very different from other speeds. It's something that's sort of a built-in property of the universe, and it sets the relationship between mass and energy and between electric fields and magnetic fields. You don't want to mess with that too much. If you change the speed of light, the round-trip speed of light, by more than a little bit, atoms might not even be possible. And so we think there's a good reason that light's always been the speed that it is today. Some people have suggested the light was created in transit. And, certainly God made the universe mature. There's no doubt about that. The first trees didn't need time to grow. God made them, already bearing fruit, according to Scripture. They didn't need time for that. Some people have said, well, maybe light's like that. Maybe God made the light. When he made the star, he made a beam of light connecting the star to the earth. And at first, that sounds really good, but I think I have an issue with that, and I don't think that's the answer, because the light in transit model requires God to create fictional images and movies of things that never existed and events that never happened. And I'll give you an example of this. Right here you see, this is supernova 1987A. So on the left panel, you see a little blue star there indicated by the arrow. And in the right panel, that's what we saw in January of 1987. That little star blew itself to bits and very briefly became extremely bright. It was visible to the naked eye, even though this is in a nearby galaxy. Now this event, I think it's 168,000 light years away. Now that's a distance. One light year is 6 trillion miles. But in standard thinking, that would mean it would take 168,000 years for the light to get from there to here. And so if you ask most astronomers, when did this really happen? They will say 168,000 years ago. Okay, and I'd say, well, that doesn't work, right? That's before creation, so that's not going to work. But you see, if you say, well, God just made the picture, that star right there, it's just a picture of a star and a beam of light about 6,000 light years long, and then he's made pictures of a star exploding and so on. It would mean that event never happened. It would mean that star never existed, and it would mean that explosion never happened. And by the way, we don't just get light from that. We got neutrinos from it too, little subatomic particles that we've been able to measure that travel at almost the speed of light. So, and by the way, here's what it looks like today. That's the remainder. That's basically star guts expanding out into space there. Okay. And if you believe that light, if you believe light in transit's the way God did it, that God made beams of light, then it means none of those exist. And I have no doubt God has the power to make fictional movies. I just don't think he would. I think it's inconsistent with his nature to create our eyes, to interpret light, the images that form from light as real, and then make fictional things to fool us. So God's not the author of confusion. And so I don't think that's the right answer. It's not a question of God's power, it's a question of God's nature. And I don't think we need it anyway. Another idea that was proposed, I think we're getting closer to the right idea, involves gravitational time dilation. Einstein showed that time does not always flow at the same rate. It's affected by things like velocity and gravity, and it is. We've been able to measure that today. We don't notice these effects because in our everyday experiences, they are exceptionally small. They're so small it would take an atomic clock to measure them. But we can't do that. Clocks at sea level tick slightly slower than clocks on mountaintops. We can measure that today, and that was by the rate that Einstein predicted. So some have proposed that maybe the way light got here is time on Earth flowed slower and time in the universe faster. But when you go through the math, I haven't been able to find it. I haven't been able to find a mathematical solution to this that works. So I don't think that's the right answer either. Okay, so those are all the things that people propose. Here's what I think the right answer is. And it's weird, but that's okay. Quantum mechanics is weird, and apparently that's the way God upholds his creation. So there you go. The solution may involve what we call the one-way speed of light. What does that mean? Well, normally when you take a look at the speed of light, we use a lowercase letter c to stand for the speed of light in physics, and it's 186,282 miles per second. Fast. But that is a round-trip time-averaged speed. In other words, that's in 1 second, light could travel that distance if it ended back at its starting destination. Let me put it this way. Let's say we want to measure the speed of light, okay? And so what we'll do is we'll build a long hallway. We'll build it 186,282 miles long to make the math easy. Okay, we'll pretend we have government funding. We can waste it that way. And then at the other end of the hallway, I'm going to put a mirror, and I'm going to stand at this end of the hallway with my flashlight. And when my clock strikes noon, I'm going to turn that flashlight on for just an instant. It's going to go travel down that hallway, reflect off the mirror, and come back. And if I did this, I would see the reflection 2 seconds later. And that's a little counterintuitive too. We look in a mirror, we think of our reflection as instantaneous. It's not quite. It's not quite. And if you were to have that distance, and that's a fraction of the distance to the moon, okay? But if we did that, it would take 2 seconds for me to see the reflection. And I would say, well, the total distance it actually traveled 186,000 miles twice, didn't it? Because it went that way and then back. And it took 2 seconds to do that. So 186,000 times 2 divided by 2, see why we did it that way. That it works out to 186,282 miles per second, speed of light. And that's true. And we've done all kinds of experiments that have demonstrated that that's the speed of light in vacuum. It will slow down when it goes into a substance like water or glass, but in vacuum, that's its speed. Now, most people assume that the light took 1 second to go out and 1 second to come back. But we don't actually know that because I can only be at one location at a time. I'm not omnipresent, okay? And so I'm where the flashlight, all I know is when it started, right at noon, and I know when I saw the reflection, 2 seconds after noon. I don't know that it struck the mirror at 1 second after noon, and neither do you. Now, you say, well, we have kind of an overhead God view here. Yes, but in a real experiment, you don't have that. In a real experiment, you don't know when it hit the mirror. My point is, it could be this. It could be the light took no time to hit the mirror, 0 seconds that way, and 2 seconds back. That would work, wouldn't it? Or it could be that the light took 2 seconds to go out and 0 seconds to come back, instantaneous. Either way, no matter which of those three scenarios is true, I would see the reflection 2 seconds later. You see my point? It's kind of like 0 plus 2 equals 2, so does 2 plus 0, and so does 1 plus 1. You don't know that the rate out is the same as the rate in. What if it's different? People say, why would it be different? I don't know, but I don't know why it would have to be the same, right? There's certain crystals where we can make the speed of light be very different in different directions. Maybe vacuums like that, as one hypothetical. In any case, if the bottom scenario is true, what if light, just by the nature of the universe, when it moves away from an observer, travels at half c, half what we think of as the speed of light, and then light coming toward an observer is instantaneous, it's infinitely fast. That would be consistent with every measurement of the speed of light we've ever done. Isn't that interesting? And I'm kind of rooting for this one to be the answer, because if that bottom one's the answer, then that means there's no starlight issue, because the light from those galaxies is coming toward observers and therefore takes no time. Its speed can be essentially infinite. Isn't that interesting? If that bottom scenario is true, but wishing for something doesn't make it so. Is that the case? Is it in fact the case that the speed of light travels different this way than that way, different inward than outward? Well, you think, well, let's do an experiment to test that. Now, an experiment to test the one-way speed of light, you don't want to use a mirror because we just want to get it in one direction, right? And so I'm going to stand here with my clock and my flashlight, and right at noon, I'm going to turn my flashlight on, the light's going to go zip out, and it's going to hit that other clock, and that other clock's got a trigger on it, it's going to record the time. Should work, right? And you're thinking it'll be 1 second. Yeah, because it's probably the same that way and that way. Well, I did this experiment in my office. I don't have the long hallway. But I do have the distance between my watch and my phone, and I can convert. Okay, so that's okay. And I did this right when my watch struck noon. I turned the flashlight on, the light went and hit the phone, and I looked at the time the phone said when it was illuminated, and it said 12:05. So I said, light takes 5 minutes to get from my watch to the phone. It felt instantaneous, but now that really happened, but that's not the right conclusion, is it? The right conclusion is, well, obviously, the clock on your phone is 5 minutes fast, which in fact, it was, so I don't miss staff meetings. But anyway, so you get the point? This would only work if these two clocks are synchronized. Oh, okay. It's synchronized, right? It means they read the same time at the same time. We know that from all those old spy movies. Let's all synchronize our watches, right? So no problem. We'll make sure the clocks are synchronized. And by the way, they have to be exactly synchronized. Because let's say it really does take 1 second to go from there to there, but that clock is 1 second slow. Then you do the calculation. You'd say, well, it's instantaneous. It arrived at noon. If it's 1 second fast, you'd say, well, it's half C. It makes an enormous difference if that clock is even 1 second off. So it's not good enough that these two clocks are approximately synchronized. They have to be exactly synchronized. Say, okay, no problem. We'll make sure the clocks are exactly synchronized. This turns out to be difficult to do. Okay? Now, the way normally clocks are synchronized is by radio transmission. In fact, I have a clock in my apartment that receives a radio transmission from Fort Collins, Colorado, that's connected to the atomic clock in Boulder. Maybe some of you have that same model. It's pretty neat. I never have to set it because it always has the correct time. Because that radio transmitter, at certain times, it'll send out, let's say noon, it'll send out a signal, and then my clock receives it and sets itself to noon. Neat. They're exactly synchronized. Or are they? Well, it's a radio transmission, and as fast as radio is, radio might not be exactly instantaneous. So in other words, if that radio takes a little bit of time to get from that clock to that clock, then that clock will be a little bit behind that one, won't it? They won't be synchronized. Now, if I knew how fast radio travels, I could calculate how long it took to get there, and then, okay, so, well, it took a second, so instead of setting it to noon, I'll set it to 12:00:01. If I knew how fast radio is. Do you know how fast radio is? Speed of light. That's the very thing I'm trying to measure. See, radio is the same type of substance as light is. They're both electromagnetic radiation, and they do travel at the same speed. We just don't know what that speed is on a one-way trip. We know what the round-trip speed is. That's unquestionable. We've done a number of experiments for that. But you see, normally we would use light or radio to synchronize two clocks. But you can't do that here because that's the very thing we don't know. Some people have said, well, maybe if you put the radio transmitter in between the two, then at least they'll be synchronized the same. Right? They'll both be behind the transmitter, but they'll be the same. Right? Wrong. Because if the speed of light's different in different directions, then so is the speed of radio. In which case, one clock gets set to noon first, and the second clock gets set to noon a couple seconds later. See that? On the bottom there? So the one on the right set to noon, and then the one on the left set to noon a little bit later. They're not synchronized. So again, that experiment assumes that the speed of light's the same in all directions, the very thing we're trying to test. You can't just arbitrarily assume what you're trying to test, right? Now, as a last resort, people will say, well, here's what we'll do. We'll take the clocks and bring them together and synchronize them, and then we know they're synchronized because they're both right there. And that's true, right? And we know that, again, we know that from the spy movies. They all put their clocks together. They're in the same place, and they read the same time. They're synchronized. And then we'll move the clocks to opposite ends of the hallway, and we say they're still synchronized. But are they? Well, Einstein made an interesting discovery. Motion affects the passage of time. The very act of moving the clocks causes them to become desynchronized, potentially. Now, perhaps not all is lost. Einstein also discovered the equation that tells us how much time is gained or lost by a moving clock. But in that equation is the speed of light. Isn't that interesting? So here's the point. And this is wild to me, and this is not something that a lot of students of science really know, but it is in the literature. Apparently, it's impossible to synchronize two clocks separated by a distance without knowing in advance the one-way speed of light. And it's impossible to measure the one-way speed of light without two synchronized clocks separated by a distance. Each one requires you to know the other one first, which means we will never know the one-way speed of light. Okay? I know that's disappointing, but it's weird. I mean, just apologetics aside, that's weird, right? I mean, let's face it, you and I wouldn't have designed the universe that way, but God did, apparently. And so and Einstein knew this, and he wrote about it. If you read his books on, even his introductory book on relativity, he talks about this issue. So anyway, so what this suggests, when there's something you can't fundamentally measure without knowing the other thing first, it suggests that the one-way speed of light is in fact not a property of nature at all, but a convention. A convention is something that we choose, we all kind of agree on it, and it works. Driving on the right side of the road is a convention. We all agree to it, works pretty well. But of course, if you go to Australia, they drive on the left side of the road. They have a different convention, don't they? And that works well for them. As long as you stick to that convention. Now, if you try to switch conventions without converting, you're going to have a car accident, right? But as long as you stick to that convention, the one-way speed of light is conventional, which means we get to choose what it is within certain limits. It turns out you can make the one-way speed of light be anything between 1/2 c and infinity, and then the return, in any given direction, you pick a direction, I'm going to make the one-way speed of light between 1/2 c and infinity, and then the return trip speed is determined by the requirement that the round trip speed has to be c. But in any given direction, you can pick the one-way speed of light. And that tells you how to synchronize clocks. And then when you synchronize your clocks, you'll find that this one-way speed of light's whatever you picked. As long as you're consistent. Every experiment is consistent with the one-way speed of light being whatever you want it to be, as long as you're consistent and within those limits. So it's pretty interesting. And what that means is I'm free to stipulate the one-way speed of light when it's moving toward me is instantaneous. And when it's moving away from me, it's 1/2 c. And you're free to make the same convention for yourself. Which means there's no starlight issue if we use that convention. And I think the Bible uses that convention. But here's what I want to point out. Let's suppose you had a lightning bolt that strikes exactly in between two clocks, and we think we'll use the light from that lightning bolt. When the clocks see the light, they get a light detector, it sets them both to noon. You'd think, well, that would be a good mechanism to synchronize those clocks if we decide the speed of light's the same in both directions, right? That light requires the same time to traverse the path A to M as for the path B to M is in reality neither a supposition nor a hypothesis about the physical nature of light, but a stipulation which I can make of my own free will in order to arrive at a definition of simultaneity. So he's saying the one-way speed of light, it's not a property of nature, it's a stipulation I can make, and that defines synchronization for me. And that's a quote by Albert Einstein. He did know about this issue, and he wrote about it. According to Einstein, we'll never be able to measure the one-way speed of light. Rather, we stipulate the one-way speed of light. And that gives us a definition of what constitutes synchronized clocks. It's weird. It's in the literature, though. There are probably hundreds of articles throughout the 20th century on this topic. It's called the conventionality thesis, if you'd like to look it up. There's even a Wikipedia article on it that's actually reasonably accurate. So there you go. The conventionality thesis. We cannot measure the one-way speed of light. We stipulate it. And I would suggest that we use what's called an anisotropic synchrony convention. Anisotropic means different in different directions. So I'm going to assume that the speed of light when it's outgoing is 1/2 c, and when it's incoming, it's instantaneous. It's infinity. And the neat thing about that is there's no starlight issue if we use that convention, because we're seeing the universe in real time. Now, what really bugs people is I'm not saying the other convention is wrong. Because according to Einstein, they're just conventions. Conventions are not right or wrong. Metric system versus British units. Feet versus meters. Which one's the right one? Wow. I'm a scientist, so we like meters, right? But if you want to use feet, that's fine. Is a table really 3 feet long or is it 1 yard long? Which is the real answer? Those are two different conventions. You see, they're equivalent. One-way speeds are like that, one-way speed of light. And the neat thing is, I think the Bible uses this convention because all ancient cultures did. So if this is the convention the Bible's using, whereby light takes no time to get from a distant galaxy to the Earth, and there's no starlight problem, all ancient cultures did that. That when they saw something happen in space, that's the time that they recorded it as happening. And that's consistent with all physics today. Now, it's not wrong to use the other method, which is to assume the speed of light's the same in all directions and then subtract off light travel time. In some cases, that makes the math easier. But the ancients didn't know the round-trip speed of light. They couldn't have done it that way. And if you think about it, that is the more natural way to do it, isn't it? I mean, if you see a deer grazing on the other side of the hill there, you say, wonder how many million years ago that really happened. No, right? It's natural for us to say what we see is happening now, if we see it happening now, right? That's natural. And I believe the Bible uses that convention. And the cool thing is it's consistent with modern physics. It's just not a lot of people know that. And I think it's implied in Scripture as well, because the Bible says in Genesis 1:14, where God creates the luminaries in the sky, God said, let them be for lights. Let there be lights in the expanse of the heavens to separate the day from the night, and let them be for signs and for seasons and for days and years. And we find out later that's the sun, the moon, the stars also. He says, and let them be for lights in the expanse of the heavens to give light on the earth. And it was so. What was so? Well, they gave light on the earth. So apparently, as soon as stars were created by God, they immediately fulfilled their God-ordained purpose to give light on the earth, which means the light arrived immediately. So I think that's suggested in Scripture. That suggests the Bible's using that anisotropic synchrony convention. They wouldn't have called it that, but that's what the ancients all would have used up until the 1600s. Nobody used the Einstein convention up until 1600s, if not later. So there you go. So we do have an answer for distant starlight, and that's what I hope you take away from that, even if you get lost in the details. I hope you get to take away that we have an answer that is consistent with known physics. And by the way, God's not constrained by physics. It's his universe. He can do what he wants. Some people say, I'm only going to submit to God after I understand how he did everything he did. You're never going to understand how God did everything he did. You're never going to understand the mechanism behind the resurrection, because God does what he wants. But I think it's interesting that the starlight issue, it's consistent with known physics. God didn't have to do anything supernatural to get the starlight here. He could have if he wanted to, but he didn't have to. And I think that's neat. So we do have an answer to that. So I hope you've seen that the secrets of the cosmos do confirm the Bible. The glory of God is revealed in his creation. The basics of astronomy, the Bible's right about those things. The spherical nature of the earth, the expansion of the universe, the age of the universe, the Bible's right about that. The Bible's right about the uniqueness of earth, and the Bible's right about distant starlight. And we now understand, we think, the mechanism that God used to do that. So we do have some resources. I hope you probably saw those coming in. This presentation is available on DVD if you want to get that, Astronomy Reveals Creation. The book that would go along with this would be Taking Back Astronomy. That covers a lot of what I talked about today. It doesn't go into detail on the starlight issue. I have another book on that. But everything else, the nebulae and the recession of the moon and so on. Worlds of Creation takes you on a tour of the solar system. We've now visited all the large objects in our solar system via unmanned spacecraft, and it's awesome. They're beautiful, and they declare God's glory. It's really wonderful. Stargazer's Guide to the Night Sky, if you'd like to learn how to find some of these things in the sky that we were talking about. There's some of these things you can see with binoculars. There's star clusters you can see with binoculars. If you want to get a small telescope, what kind you might want to get and how to use it. But even if you don't, when's the next meteor shower? You don't need a telescope to see that. Or, got a solar eclipse coming up in a couple years. That'll be cool. So there you go. Understanding Genesis. Does Genesis really mean what it says? Did God really create in 6 days? Yes, it does. And this will show you how to defend that biblically. We go back and look at the languages and so on. And we have a DVD on that topic showing the importance of a literal historical Genesis. The ultimate proof of creation, if you want a bulletproof argument for biblical creation, this is it. And it's very different from most arguments that people make. You don't have to know a lot about science, things like that, to be able to make a bulletproof argument. It's basically training you how to think and debate the way Jesus did in his earthly ministry. And Jesus was not the kind of person you wanted to debate against. We have a DVD on that as well. His star, what about the star that guided the Magi to the Christ? Have you ever wondered about that? We have a DVD on that. I'm aware there's another one that was done by a lawyer. I don't think he's right, but in any case, there's my answer, at least what I think it is. Created Cosmos is the planetarium show I wrote for the Creation Museum a number of years ago. Takes you on a tour of the universe from a biblical perspective. It's really neat. And then we have the physics of Einstein. If you'd like to learn more about the one-way speed of light and other issues, like what about black holes and time travel? There's a chapter in the book on how to build a time machine. So there you go. If you like it, send me a letter last Thursday. Okay. By the way, this book, it's written for laymen, but if you say, well, I'd like to go into a little more detail, it does have in-depth boxes if you want to go through and see how the math works out, but you can skip those if you want. So I try to write to a large range of demographics. So Keeping Faith in an Age of Reason answers over 400 alleged Bible contradictions. You've heard the critics say, well, how does this verse contradicts that one? How can you... Well, they're easily answered. So that's if you've heard one of those, the answer is probably in that book because it's, again, over 400 of them. Introduction to Logic. Boy, This is something we need in our society today. Yes. How to use your brain properly and to the glory of God. And the neat thing about this is it's done from a uniquely Christian perspective. It's going to train you how to think logically. It's how to avoid errors in reasoning, what are called logical fallacies, how to spot those. And because arguments against Christianity, they're fallacious, and it's good to know something about that. If you want to use this as a homeschool thing, we have a teacher's guide as well, so you could do that with tests and quizzes and answer keys and so on. The secret code of creation. This one's neat. This is going to show you that God has built incredible beauty and complexity into an aspect of creation you probably never even thought about. And it is wild. And I dare say there is no secular explanation for what you're going to see on that. And it's incredibly beautiful. We have that on Blu-ray as well, in case you want to get the really pretty version. And we have a book on this topic as well now called Fractals, The Secret Code of Creation. Every shape that you see in that book, all those beautiful works of art, no human made those. Those are built into numbers by God. Somebody asked me, who did your cover? I said, well, it was God. I mean, I have to admit, I signed the colors, but the shape is God's. The way to get everything really is to get our book pack. This, if you want to get the best books at a discount, not all of them, but most of the books are included in that at a 20% discount, so that's a nice way to get these things quickly. You can get all of our DVDs for a 20% discount, or you can get the best of everything, our library pack. Come on, you want this stuff. So get the pack, get it. This is 30% discount, and we only do these at conferences. Okay, you can get the books individually on the website, but the discount, you get that here tonight. So ask for our library pack, and then you'll have an instant creation library that you can refer to. We brought some children's resources too. No, I didn't write these, but I highly endorse them. They're very well done. We have the answers book for teens. We have answers books for kids, beautifully illustrated, nice, succinct, theologically correct and scientifically correct answers. One Blood for kids. Racism is becoming an issue again. Have you noticed that? And the solution is the Bible, to recognize there's only one race, the human race. We're all descended from Adam. We all need Jesus. And that's going to show you how that works and how the little genetic differences and so on are fleshed out. We do have a free monthly newsletter. Please sign up for that. It is free. It's an electronic newsletter, so make sure you put your email address or you'll get nothing. Okay, so do sign up for that. And there's no catch here. We just want to bless you. It comes out once a month, and just a way of keeping you informed of what we're doing in the ministry. So please take advantage of that. Not too many things free in this world, just salvation and our newsletter. So there you go. And check us out on the web as well, biblicalscienceinstitute.com. I got a new series on quantum particles that's we're in the works, and so you might check that out. Lots of great information on that website, another free resource for you. So thank you very much. We're going to come back in about 10 or 15 minutes and do a Q&A. If you want to stick around, if you need to leave, then it's been great. So thank you very much. God bless.
You're a great encouragement.
Thank you.
Thank you. The question I have is about the sun and its effect on climate.
It's a major factor in climate because the sun, of course, provides the earth with energy and light. The sun goes through natural cycles. There's a 22-year magnetic cycle, which results in an increased amount of sunspots every 11 years. And that does have an effect on temperatures on Earth. It's a little counterintuitive. You'd think when there's more sunspots, you're getting a little less light. It's the opposite. The rest of the sun overcompensates when there's more sunspots, and it actually puts out a little more energy than it does. And so the Earth's temperatures tend to be warmer when we have what we call magnetic maximum or solar maximum, where the sunspot cycles are. But there's also larger scale cycles, and we don't know how those work out because we've only been observing sunspots for about 400 years. So since we've had the technology to do that, in terms of being able to see them, up close. So, for example, there was a period of time in the late 1600s called the Mondor minimum, where there were very few sunspots. It was just even at solar maximum, there were just not that many, and that corresponded with lower temperatures, at least in Europe and perhaps around the world. It's sometimes called the Little Ice Age. So the sun has a lot to do with climate. The sun has to do with climate change, probably far more than anything human beings have done.
Thank you again.
Sure.
Appreciate your coming. When you were doing the speed of light discussion, one of the things that popped into my head, and I know virtually nothing about this, but I thought of quantum entanglement. Can you address that?
Quantum physics is weird. Quantum entanglement is, I think, the weirdest part of quantum physics. Basically, particles, when you're not looking at them, will behave like a wave, and a wave is extended into space. Think of the ripples. You throw a rock into a pond and the ripples go away, right? So where's the wave? Well, it's kind of everywhere. It expands, right? But particles will do that. They'll kind of expand. They'll have a wave function until you observe it. You do some kind of process that will observe that, and then they will choose one of the spots where the wave is either a strong peak or a strong trough, and the particle will exist there and only there. Collapses the wave function. Very strange. It turns out that two particles that have been associated with each other become entangled, and it's a quantum physics term, meaning that they continue to know about the other particle, maybe two particles that have been created from a common source, and so you get an electron that's ejected this way and a positron that's zips away that way. And it turns out that when you observe the wave function of this particle, it immediately collapses the wave function of the other particle, which is strange. But there's no way to use that to transmit information. So in other words, you might be thinking, well, we could have instantaneous we could set up a base on Alpha Centauri. We could have instantaneous communication because I could measure these, the wave functions here and break down these particles, and it would immediately affect those particles if they've ever been entangled. But it turns out you can't do that because we can't actually see the collapse of a wave function. So there's no way to tell cause and effect. It's a very strange phenomenon. Basically, you wiggle a particle over here, it wiggles a particle over there, but there's no way to tell which is the cause and which is the effect. It's very strange.
So when it comes to the speed of light, then no application to that issue.
So when it comes to the speed of light, there's no application. That's right, because there's no way to use it to synchronize clocks because you don't know when it happened. All we know is that there's evidence that it does collapse the wave function of the other particle. So you measure this particle spin up, the other one will definitely be spin down, but there's no way to use that to synchronize clocks. It's a weird phenomenon, and I don't pretend to fully understand it.
Who holds the record on that now? Of entangled particles?
Who holds what?
I don't know who hold. Last time I think it was 8 entangled particles.
Oh, I don't know.
Oh, okay.
Yeah, I don't know.
The other question I had was the Higgs boson particle. Do you have any insight why they called it the God particle?
Yes.
Because I was under the assumption all particles were God particles.
They are. They are all God. Yeah, they call it the God particle. Now, it's not. I don't think it was intended to be irreverent, and most physicists don't use that term. But there was one who published a book on it, and it was kind of popular. Basically, the Higgs particle is associated with a field that sets the mass of all other particles in the universe. And so because it controls all other particles, that's how it gets that name, the God particle. So basically, particles that interact with the Higgs field very strongly have lots of mass. Photons, which do not interact with the Higgs field, are massless. They have no mass at all. So it basically sets the mass of everything else in the universe, hence the God particle. I don't call it that myself, just the Higgs boson. Yeah.
I got a question on the, I heard something, because over at where I work at the greenhouse, they have on the chimes or sounds of Mars or anything, and they said that in space you can hear the sounds of each planet has a sound. Have you ever heard anything like that? Or
Okay, the closest that I've heard of that is not with planets, but with stars. Stars do pulsate. They have motions within them. Now, sound doesn't travel through space, so you can't hear them. But we can measure the pulsations of these stars and turn it into sound, turn it back into sound. And I've heard them, and it's some of them sound really strange. Some of them sound like kind of almost like a phaser on Star Trek. They sound really, really strange. Most of them sound kind of like static. I've heard the sun's signal, and it sound, if you turn to a radio station where there isn't one, it's kind of what it sounds like. That's what the sun sounds like. So it's they sound cool. They're not musical. They don't make notes or anything like that. So the music of the spheres isn't quite what we thought it would be. But yeah, they do pulsate. Stars do pulsate and vibrate in many different ways, and we can take those pulsations and turn them into sound. Usually we have to speed it up to get it within the frequency range of our ears.
My question was with like the speed of light.
Mm-hmm.
So if it's like traveling infinitely in this direction at infinite speed, traveling at half speed in the other direction, then wouldn't this everything like all the stars on this side you could see, but wouldn't you not be able to see any from the other side?
Gotcha.
because Traveling at half speed.
So the answer is, it's the way I'm defining it. The anisotropic synchrony convention is all incoming light is infinite. So if light's incoming that way, it's infinite. If light's incoming that way, it's infinite. But if I send it away from me, it's half c that way. If I send it away from half c, it's one of the things you'll find that Einstein discovered is that some aspects of physics are observer dependent. So it depends on your reference frame. So I'm allowed to have my own personal coordinate system. And I'm allowed to say when light moves away from me, it's half c, and when it moves toward me, it's infinity. And so I can see the entire universe that way. And the weird thing is you can do that too, and then we can, of course, get into disputes. If I say, well, the light beam's going away from me toward you, I would see it as half c, you would see it as infinite. And I would say, well, that's because your clocks are not synchronized. And you would say, no, it's because your clocks are not synchronized. And according to Einstein, we would both be right. That's part of the weirdness of relativity. My book, The Physics of Einstein, covers some of those issues.
I have two questions. One is, would you, from the Bible, Ezekiel's wheel, would you coordinate that with things that are happening in astronomy, or is that more on a spiritual plane? And number two, the Hadron Collider, is that a real thing, and what are they actually trying to do with that?
Okay, so the first part, Ezekiel is given a vision into the heavenly realms, and so in order for God to do that, because God's a spirit, he's invisible, angels are normally invisible, God can give them a temporary body, which he has done at some, in the past. Ezekiel's given a vision, therefore, and therefore God had to make it visible so that he could see that. So it represents, the wheels in particular were for the cherubim, which are apparently an angelic being, and the wheels represented their motion. They could move in two overlapping wheels indicated that they could move in any direction. Okay, so they're like the queen on the chessboard. They can go anyway. And that's what that illustrated, because that's the way they were used in that. So it has a symbolic significance. It indicates that these creatures, these spiritual creatures, can go wherever God commands them to go. So it's not something that corresponds to the physical cosmos. And then with regard to the super colliders, the Hadron Collider, there's several. There's Fermilab, and what they do is we're trying to understand how particles behave at the smallest scales. And in some cases, the best way to do that is to give them an enormous amount of energy and create new particles. Because it turns out, although we can't make new energy, we can take energy that God already has in the universe and transform it into new particles. And one of the ways you do that is you take two particles that already exist and you slam them together at an enormous speed, so a substantial fraction of like 99.999% the speed of light. And what they'll do is they'll take a proton and send it around this way using magnetic fields to accelerate it, and they'll take another one and swing it around that way, and eventually the two collide, and they can time it to where most of the time it'll miss, but if you get enough of them, eventually two of them will collide. And then they have detectors that detect the particles that are created from the energy in that collision. And so they've been able to discover new particles. They've been able to discover, the delta, the lambda, all these different names, certain mesons, the pion, and so on. And each one of these that we discover tells us something about the way that God upholds his creation. It tells us about the rules for how particles behave, which are controlled by God, and it tells us which kind of particles can exist, which are controlled by God. And there are only so many fundamental elementary particles that God made. There's 6 leptons. An electron is one member of that class. There's 6 quarks, but quarks can be combined in different ways to make protons and neutrons and these other particles. And so in a relatively small number of particles, God has constructed everything that exists, and it's amazing. It's mind-blowing. And so the current series that I'm doing on the website, we've just scratched the surface on that. But I'm talking about these quantum particles, and it's amazing too, because the rules have to be a certain way. And in the latest article, I talked about spin states. Particles act like they're spinning. They're not really spinning, but they sort of act like it. And there's spin half particles and there's spin one particles, and they behave a little differently. And so what if God had made electrons spin one particles? Electrons are spin half particles. What if he'd have made them spin one? Chemistry would be impossible because all the electrons would drop down into the lowest state. You see, fermions can't occupy the same state at the same time. So you can only put 2 electrons in an atom shell, one spin up, one spin down. But if electrons had spin 1, they'd be bosons, and they could all fall into the lowest shell. Chemistry would be impossible. It's just amazing to think through the logic that God thought through when he made these small number of particles that make up everything else and the rules that bind them. It makes life possible. It makes the cosmos possible. It's amazing.
And then playing with that, I mean, do you deem it safe or they kind of like experimenting?
Is it safe? Yeah, it is. Because even though the energies that are released are magnificent by quantum standards, they're microscopic. And the particles that are produced are almost always unstable unless they produce things like protons. Most of these other particles that exist that are combinations of quarks have a very fleeting existence. They last like less than a millisecond, and then are gone, and they decay into something else that's a little more stable. So they can't go very far. Okay, and so anything outside the laboratory is not going to be remotely affected, or even just a few feet away. They peter out. So it's perfectly safe.
I guess in my mind, I was thinking, like them experimenting with nuclear stuff.
Right. Okay. So the difference with nuclear material is they take nuclear material can generate a chain reaction. They would take, well, in the old days, they would take something like uranium or plutonium, and if you concentrate it sufficiently, it'll generate a chain reaction because these particles are only marginally, they're slightly unstable, and when you collect them, the reaction from one, it's like a domino effect. It'll trigger a reaction in another, which triggers a reaction, and so on, and it generates a chain reaction. But you can't do that with just a handful of protons. A chain reaction would not be possible.
Thank you.
Sure.
My questions will just expose my ignorance, but I'll go anyway. The difference from your reference point, I mean, velocity or anything else is all dependent on what your reference point is. So is it kind of like sound coming toward you will increase in frequency, shorter wavelength, versus sound going away from you has a lower frequency, longer wavelengths? Is that the kind of the idea with light being infinite one direction or the other, or is that a different principle altogether?
It's a different, though related principle. You do get that with light too. That's a Doppler effect. But the weird thing about light's weird. If we take let's take, for the sake of argument, the Einstein synchrony convention, where we'll make the one-way speed of light the same that way as it is that way. It turns out that if we assume that convention, it's not just that the light is c that way, it's c faster than me that way, no matter how fast I move. So in other words, if I shine a light beam out like that, and I'm measuring it going away at the speed c, and then I accelerate to half c, you might think, well, it'd only be going half c faster than me now. But it's not, it's still c.
Right.
And Einstein realized the solution to that is that motion affects clock rates and lengths. And we have to use clocks and lengths to measure the speed of something.
Okay.
And time will adjust and space will adjust to keep the speed of light constant. It's remarkable, but that's the way God made his universe.
All right. I have 3 more questions, unless I'm hogging the time.
Go ahead.
The second one is naval laboratory things over the last 20 years, it's probably longer now. Studying is speed of light slowing down, is playing constant, and your thoughts on that? I would lean to, based on what you said earlier, you're holding that it is constant,
Yeah.
and those are just laboratory experiments with deviation is
Yeah, there's always
based on their ability to measure it.
Yeah, there's always experimental error, but yeah, and I haven't seen any evidence that it's changed because we can measure it so precisely today. 186,000, 282.397 miles per second. I mean, we got it that precise. So yeah, so it's yeah.
All right. Second one is with time being like the speed of light, and looking at that is relative to my reference point.
Mm-hmm.
If I'm on a particle, such as planet Earth, flying through the universe, expanding, versus if I never move from the center of where God created, would time be different? In other words, if I'm at the center and I'm looking out at this, would I say that's 6 days? But if I'm on an object flying at the outer periphery, would time look different?
Yeah, it would. Time would appear to tick slower if you're moving away. So the accumulated time would be less than 6,000 years. So
Okay.
yeah,
So it's the opposite of the way I'm thinking.
yeah.
All right. I'll have to go back and think that one. Final question. Dark matter versus with gravity versus looking at the universe more from an electromagnetic force,
Okay.
explaining some of the movements versus looking for dark matter and that we don't know exists, and using that to say that's affecting gravity versus the way electromagnetic things behave. Any thoughts on which is more of the real solution?
I think dark matter is a better solution. So it turns out the electric field, although it's very powerful, it's so powerful that everything tends to neutralize very quickly. So if something has a slight positive charge, it will attract an opposite charge,
Right.
and neutralize itself. And so on large scales, the electromagnetic field is largely neutral. There are weak magnetic fields that thread through galaxies, and we can detect that. We can detect electric fields too. They're minuscule though. On cosmic scales, gravity wins because even though it's a weaker force, it accumulates. There's no negative mass charges. It's 100% attractive, whereas the electric force can be attractive or repulsive depending on the charges of the particles. So on the largest scale, gravity wins. And with dark matter, there is good evidence for this. There is good evidence that there's a lot of stuff in the universe that we haven't discovered yet. And as a Christian, I don't have a problem with that, I think.
Right.
Yeah, of course. But there's good evidence for it in that the way stars behave, the way they orbit suggests there's more mass interior to their orbits than can be accounted for simply by the gas and dust and everything we can see and everything we can estimate by what we see. But we don't know what it is, but also the way it bends light, too,
Right.
would be consistent with gravity and probably not with an electric field.
Any of your books deal with gravity as far as topic?
Well, yeah. The physics of Einstein goes into it a little bit. There's a chapter on black holes and how gravity affects space-time. And the black holes chapter, I think it's a lot of fun because black holes are just cool. They're just neat. So there's that. And then also in a few weeks, I'm going through the quantum particles. At some point, I'll come up to gauge bosons and I'll talk about gravitons, and we'll talk about gravity. So in just a few weeks on the website, you should see that.
Fair enough. Final question, because I'm cheating already. Light has speed and it takes time and distance. Gravity seems to be almost instantaneous. Any thoughts on that?
Actually, gravity travels at the speed of light.
Okay.
So yeah, if the speed of light's different directions, so is the speed of gravity.
Thanks.
Sure.
I didn't know that.
Mm-hmm.
Not as technical as all these others, and very good questions. Tim and I were talking during the break, what's the point of all this in terms of why does mankind in the secular world, as you refer to it, pursue so rapidly the knowledge and the understanding, and then the Christian the same way? What's the point? And there's two different points we think. Just your thoughts on that.
Yeah, of course, my goal is to glorify God and enjoy Him forever. And science ought to be done to that end, in my view. It's to understand the way God upholds His creation and to worship Him as a result of the awesome way that He upholds His creation. Now, secularists, they may deny being made in God's image, but they cannot escape being made in God's image. And so that same desire is built into them as well. They are made to be curious creatures because that's the way God made us and to want to explore God's creation. They know God in their heart of hearts, but they suppress that truth in unrighteousness. That's what the Bible says in Romans 1. So when I see scientists doing commendable things and smashing particles together and learning about how God upholds His creation, but then failing to give God glory for that, it's just Romans 1. I'm like, their knowledge of God leaks through. Their behavior shows that they do know God. Because if this were a chance universe, it wouldn't make sense to do science at all. Because why would there be any order at all in a universe that's just chance? This universe is upheld by a mind, which is why we can write down equations that describe the behavior of things. Math is a mental process. And so the fact that the universe obeys math it's an evidence of biblical creation. The physicist Eugene Wigner, who was a Nobel Prize brilliant man, but apparently not a Christian, wrote a wonderful article that I often like to cite called The Unreasonable Effectiveness of Mathematics in the Natural Sciences. Unreasonable, because from his worldview, it doesn't make sense that nature should obey math, because math is what you do in your head. It's conceptual. How does the universe know what goes on in my head? Why, well, it's because God's mind is conceptual as well. We're made in his image. And the universe obeys God's thoughts. God speaks and the universe behaves that way.
So there is no excuse.
There is no excuse. That's right. Of course, that's what the Bible says. And again, in Romans chapter 1 and 20, verse 20, no excuse, no apologetic, no defense.
I just want to know your thoughts on CERN.
It's another super collider. CERN, the super collider?
It is a super,
Yeah.
so it's the same thing as he was talking about.
Mhm.
And you really don't believe there's dangers with it, with some of the things that we've read?
No,
Okay.
there's no danger in it. I did see an awesome video, because some people were saying, oh, they'll create a black hole.
Yes.
And I saw this awesome video. It was so well done, where they showed the internal workings of CERN, and the other video was the parking lot. And you see the flashing lights go on. You see this black hole form, and then the parking lot gets sucked into it. It was so funny, but no, that's not going to happen. The energies involved are as high as we can get them, but they're still tiny compared to anything in the real world. Yeah.
I worried about it for years, so it's good to hear.
Yeah.
I have a question from my friend. This is a little comic. She wants to know if you believe men are from Mars and women are from Venus. And I'm
No comment on that.
Hello.
Hi.
I had a quick question. What do you know about dark matter?
Dark matter is matter that we know it's there because it's pulling on something else, but we don't know what it is. So we can't see it. That's why it's dark. One example, did you know the planet Neptune was once dark matter? Because scientists, when they discovered, planet Uranus was discovered by Herschel, and scientists began watching how it orbited the sun, and they found that it was off from their predictions. And two mathematicians, independently, they didn't know each other, they realized that the reason that Uranus was moving differently is because there must be another planet out there that's pulling on it. And in fact, these two mathematicians, John Couch Adams and Leverrier, they independently calculated the position of this new planet, and they told the astronomers, if you point your telescopes there, you will see a new planet. That's a pretty bold claim. See, they knew it was, they didn't know, they hadn't seen it yet, but they knew it was there because its gravity was pulling on something they could see. And sure enough, astronomers discovered the planet Neptune. But so now it's not dark matter anymore because now we can see it. Dark matter is like that. It's substance that's out there, and apparently there's a lot of it. And we can't see it, but we know it's there because it's pulling on stars. So the way stars move tells us there's something pulling on them, and we don't know what it is. That's a little reminder too that God sometimes gives us little things like that just to say, you haven't really got it all figured out. Okay.
I had one more question.
Okay.
Why does time change in the event horizon of a black hole?
Okay, in the event horizon of a black hole, well, let's see, how do I explain that? That's a tricky one. There are a couple of things that can affect the flow of time, and they do this in order to keep the speed of light constant relative to any observer, the round-trip speed of light. So, and that's counterintuitive, because we'd think, if I shine a flashlight, it's going the speed of light faster than me. If I then move at half the speed of light, you'd think it'd only be going half the speed of light faster than me, but it doesn't. It continues going the speed of light faster than me because my time adjusts and my rulers adjust so that when I measure the speed of light, it's still the speed of light. And that's kind of a neat thing because in Scripture, light's often an analogy for God's purity and His holiness. And so I think it's interesting that the entire universe bows to keep the speed of light the same. And it's not space and time that light has to obey. It's space and time that kind of obey light. Now in black hole, what happens is you can think of space, empty space, as kind of the surface of a lake. And somebody pulls the plug in the middle of the lake and the water starts to funnel down, okay? Now at a certain point, that water, you could imagine boats on the lake, and light would be like boats that have their throttle stuck on full. They can't go any other speed than maximum, okay? And so these little photon boats are zipping around the lake, but at some point that water is falling in at the same speed as the boats. That's the event horizon of a black hole. And so a particle of light can try to get out of a black hole. It's trying to swim upstream like salmon, but the water's going under it at the same speed it's trying to go up, and so that's where light will get stuck, at the event horizon. And so if you're inside the event horizon, in order to remain stationary, you'd have to go faster than light, and if you can go faster than light, you can go back in time. And the details are a little bit complicated, but that's what happens there. At the event horizon of a black hole, space and time kind of switch, because normally we can move in any direction in space, but only one direction in time, forward. Inside a black hole, one direction of space flips with time. Now we can go forward or backward in time, but you can only go one direction in space, in. So you're going to die. So it's not a good thing to try. Sure. That's a good question.
All right, I got a twofer.
Okay.
The first is there anything on like the secular science sunset that, like, is there any more challenges? I'm sure they're always challenging everything we believe, but is there anything on the sunset to be aware of, I guess, that will become popular or is becoming popular, or, you know?
Well, yeah, I mean, the Webb telescope, the James Webb telescope, I've made some predictions about what it's going to see that are different from the secularists. And so I'm very interested to see what will happen next month, because that's when the first data will come back. I'd love to see them do it, Hubble Ultra Deep Field. They're predicting they'll see galaxies in the process of formation, starting to form. I'm predicting they're going to see fully formed galaxies, just like the Hubble did. So that's my prediction. And in a few months, we might know that. We might have the answer to that. So that's exciting for me. There's all kinds of stuff in quantum physics and particle physics, trying to unify the three forces that we kind of understand, electromagnetism, the strong force, and the nuclear weak force, with gravity. Currently, there's no way to connect those two. Gravity deals with situations, where there's a lot of mass. Quantum deals with situations that are very small. There's no physics that deals with small situations that have a lot of mass. And that's what string theory and superstring theory, those are attempts to reconcile. So those are very exciting as well, but nobody can think of ways to test them. So, but yeah, there's always stuff on the horizon. Yeah.
And then, do you take evolutionary questions?
Yeah, sure.
Or whatever. So I guess I did some Googling. Like Darwinism is based on natural selection, and then neo-Darwinism or modern Darwinism is like a genetic focus. Mm-hmm. And then I was mowing the lawn, I was listening to a podcast, and they were saying that, top scientists in the secular world are seeing that neo-Darwinism, or the most modern version of it, is not sufficient to explain the life. And so what would they look up next? I mean, they've gone through natural selection and then genetics. And I've listened to a lot of creation podcasts and saying that genetics, everything for change is front-loaded into genetics. And then we see it as it goes, not the other way around, where genetics is being added onto.
Right.
And so they're always going to come up with something, but is there any idea what they'll look to besides genetics and natural selection?
Yeah, I'm not sure. So neo-Darwinism is the idea that life evolves by mutations and natural selection. So mutations are supposed to generate the new information in the DNA, which has never been observed. And then natural selection weeds, is sort of a culling of the unsuccessful cases. And that we do observe. Natural selection it's a biblical principle. In fact, a creationist, Edward Blythe, who wrote about, he didn't call it natural selection, but he certainly wrote about that topic, and he saw it as God's providence, that animals, or especially with plants, because with plants they're not really alive in the same way that animals are, and so if a seed doesn't take in a particular climate, that's no big deal. But creatures fit the places that God designed them to, and they have an ability to adapt within a certain degree. But there have been devastating challenges to the neo-Darwinian model, and Michael Behe, who actually believes in evolution. He says that in his book. His book, Darwin's Black Box, which I read a number of years ago. It's a good read. Even though he's not a creationist, he presents some amazing, compelling evidence that the mutations and natural selection model is never going to result in evolution. And you can't even get it started because the first cell is irreducibly complex. The cell is made of parts that have to all work together or the cell dies. And so which part came first? They all had to come first, you see. Did the DNA come first? Well, the DNA is useless unless you have being transformed into messenger RNA, which is useless unless it's read by the ribosomes. And by the way, the instructions to produce the ribosomes are on the DNA. It's a phenomenal system, but only God can create the first cell. I don't know if Behe thinks that. I don't know. I don't know what they're going to go with next, but it won't be God. It's the ABC method, right? Anything but Christ. And so I don't know what it'll be, but it'll be some other chance process, I suppose. Okay. Yeah, sure.
I think I saw this recently or read about it or something. So if black holes exist, pulls everything in, then do white holes exist that repel everything? And if white holes existed, we could never see them, right? Because nothing's surrounding them.
Okay. There's good evidence that black holes exist. There's good evidence that white holes don't. Now, general relativity, the physics that Einstein discovered, allows for both, because there's sort of two solutions. You can have basically a white hole. If you watched a movie of a black hole and stuff falling into it, and then you played it backwards, that would be a white hole. So nothing can go into a white hole, but it's constantly ejecting stuff. Okay, it's like a time-reversed black hole. Now, general relativity is time symmetric. It works perfectly well either way. But general relativity is not the only physics that the universe has to obey. It has to obey some other physics too, including thermodynamics, which has a preference for things going from past to future and not the other way. So when you combine our knowledge of black holes from general relativity with these other aspects of physics like thermodynamics, we think it's very likely that white holes do not exist. They probably violate thermodynamics. But there's good evidence black holes exist. So very compelling evidence for black holes.
That just triggered another thought that I had, and I don't know the answer to this at all. Just playing around with things. Time is a vector. It has direction. It's moving one direction from most everything I can see. But most of the time growing up, I've always thought of it as linear. Recently, I've been thinking of it more of a sphere expanding. Any basis for that whatsoever? With a beginning of time that God has created, and then instead of expanding in a linear fashion or even a number line in two different directions, it's coming from a point and expanding as a sphere. It's just a conjecture I've had in my head. I don't know if there's any basis to it.
Okay, well, time isn't it's not a physical thing that exists in space. It's a dimension. So, and we think there are 4 dimensions. There are perhaps others that quantum particles can feel, but there are at least 4 that we're aware of. And X, Y, Z, and time. And it turns out that they're not the independent thing we assume that they are. It turns out that what one observer sees as space only, another observer might see as a combination of space and time. Let's say 2 events happen, event A and event B, 2 lightning strikes. And one observer says, well, those happened at the same time. Maybe he didn't see both at the same time, but he subtracts off the light travel time. Maybe he's using the Einstein synchrony convention. He says, these happen at the same time. Another observer that is moving relative to him, saying, no, the speed of light's c relative to me, will not conclude in general that they happen at the same time. One will happen before the other. If he's moving toward it, the one that's further ahead happens first, and then so on. That's called the relativity of simultaneity. Einstein discovered that. Einstein also discovered there is a combination of space and time that's the same for everyone. That's called the space-time interval. And basically you take the distance separation between these 2 points, which would be the change in x squared plus the change in y squared plus the change in z squared, square root of that. Well, you take that and you add it to you subtract the time for it. And you have to include c, the speed of light, in there to get the units correct. So that squared, you take the square root of all of that, and that's called the space-time interval. It's like a distance in space and time that everyone agrees on. Okay, and so it's invariant. It's invariant under Lorentz transformation. So no matter how you're moving, the space-time interval, everyone agrees on it. Okay.
I have 2 questions.
Okay.
The first one, how do sunsets work?
Okay, how do sunsets work? The Earth, we're on a rotating planet. And so as soon as the sun is below the horizon, it looks from our perspective, because we're rotating with the Earth, like the sun's moving, right? Actually, we're rotating, but nonetheless, as soon as it goes over the horizon, you don't see it anymore. So that's when it's below due to the curvature of the Earth. You can actually see, it's interesting too, depending on where you're at, you can prove that the Earth is round using sunsets. If you go to, let's say you go to California and you go to the beach there and you're looking west and you're lying down and you see the sunset, as soon as you see that last little piece of sun disappear, stand up and you'll see another sunset. You'll see another 7 seconds because of the curvature of the Earth. You can't see the sun when you're down there, but you can when you're up there. So you can use sunsets to prove the world's round. How about that? You had a second question?
Is the sky blue, or if something didn't happen, would it be another color?
Okay, the sky is blue because of what's called Rayleigh scattering. And that basically means that light, when it comes into our atmosphere, occasionally it'll hit an atom and go in a different direction. And it turns out that process, that scattering process, is more effective with light that has higher energy, which you can think of as having a more bluish color. Light that is red has less energy. Light that is blue has more energy. And so more of the blue light gets scattered than the red light. A little bit of the red light gets scattered too. But that's why the sky is blue. So some of that light that's coming from the sun, which has all colors in it because it's almost white, so the blue gets scattered away, which makes your sky blue, and then the rest of it you can see as the sun, which you shouldn't look at, but that's what it is. And then when the sun sets, you're now looking through a lot more atmosphere, and all the blue's been scattered away. So the reason sunsets look red is because that's the only light that's left. The blue's been scattered away, making somebody else's sky blue, and so you see the red that's left over. And so that's the natural way. Unless there's some kind of chemical that would change that, a blue sky is what you'd expect on most planets. Even Mars has a blue sky most of the time. Occasionally it turn pink if it gets dust blown up into it. But yeah, it's a good question.
One of the points that you discussed was the ratio of energy absorbed by the planets and then that amount emitted. Mm-hmm. Is there a principle that's associated with? Because when I was trying to Google that for what the value for the Earth was, strangely I get 1,000 hits on climate change and what we're doing wrong.
Okay. Is there a principle there? Well,
what would I look up in a Google search to find out what the Earth's ratio is?
Internal heat of the Earth, probably. Internal heat is what that's called.
Okay.
And the Earth does it too. But with the Earth, the secularists have an explanation for it that kind of works. So I don't use that one. Because it turns out radioactivity generates a little bit of heat. And so they'd say the reason that the Earth gives off a little more heat, a little more energy than it receives, and I don't know what the ratio is for the Earth off the top of my head, but it does. It gives off more than it receives. But they'd say it's because radioactivity, radioactive elements have been doing that. But see, Jupiter is made of hydrogen and helium. It doesn't have radioactive elements. So it's not going to work for any of the outer planets.
Okay. I appreciate your discussion. Thank you.
Sure.
So I learned this in high school, so that was a long time ago. So maybe the science has changed, but I remember my teacher telling me that the Big Bang was basically all the matter in the universe was collected into a singularity, and that singularity was like a point, a very small point. And I should have asked then, but I always wondered, I can't get that chair into a small point. How does the entire universe get into a point? So was he wrong? Has the science changed, or how do they argue that?
A little bit of both.
Okay.
It's not just that the matter is contained. People tend to think of the Big Bang, again, which I reject, but I want to make sure you understand the story. People tend to think of the Big Bang as all the matter in the universe in a point, and all the energy in a point, surrounded by empty space. And that is not the picture of the Big Bang that the secularists believe in. They believe that space itself is contained in the point. So it's not even surrounded by vacuum. And if you can't picture that, I can't either. But because we're three-dimensional beings in terms of space, that's the way God wired us. But they would say that space itself is contained in that point. So it's what's called a naked singularity. A naked singularity is a singularity that's not surrounded by even space. It has no event horizon around it. And in terms of how you get all that stuff in there, I don't know. But then again, it's not my hypothesis. I think the secularists would say that we do know that matter has limits in terms of, like normally I can't push my hand through that because of what's called electron degeneracy pressure. So the electrons in my hand repel the electrons in this. And so I can't And that's a strong force. But there are situations where gravity can overcome that. Neutron stars, for example, the atoms collapse in a neutron star because the pressure is such that it forces the electrons into the protons in the nucleus of an atom, and they all become neutrons. But then even it's held by the degeneracy pressure of the neutrons. And so there's a limit where even the neutrons can no longer support their own weight, and theoretically it collapses into a point that doesn't have any it doesn't have any particles in it, because there's no particle that could exist there, but it's nonetheless just a mass, a point of mass. And we think that does happen in black holes, but they're surrounded by empty space, so that's sort of normal. The weird thing about the Big Bang is you have even empty space contained in the point, which is very strange. It's a very strange concept. But there are lots of problems with that, because they would say that this energy, as it expands, the energy became matter. Now, we can do this in a laboratory. We can make matter from energy. We can take protons together, slam them together, and get a new particle, get a new proton out of it. But every time we do that, we get an antiproton. Every time. Anytime we make a particle of matter from energy, we get an exactly equal amount of antimatter, which is the same as matter, but the charges of the particles are reversed. And yet the universe is almost entirely matter only, which is a good thing, because when matter and antimatter touch, they destroy each other. Okay, so God made the universe primarily matter for our benefit, or we couldn't be here to talk about it. So this is called the baryon asymmetry problem. How is it, if the Big Bang's true, that the universe does not have an exactly equal amount of antimatter? And that's still a problem. It's been a problem for decades, but it's still a problem. And there are speculations as to the solution, but there's not a firm commitment to it. So that's just one example of one of the problems with that scenario. Any others?
This might be out of the field a little bit, but
Okay.
I was just thinking the other day on the where they were like, in school we learned there's this whole new ozone layer, and it's like, well, is there one? And if so, did God create it there with the creation, or did that come out in the flood, or?
Okay. There is a deficiency in ozone over Antarctica, where nobody lives, so who cares? But I mean, yeah, there is an ozone hole, as it were. Did human beings cause it? Maybe. There is some evidence that what they call chlorofluorocarbons can damage ozone. They can, when they interact with ozone, they can destroy it very effectively. And ozone's created, though. It's created by things like lightning will create ozone. So there's the Earth itself will replenish that. But that's one of the reasons why they cut down on certain chemicals, certain refrigerants. They use a different refrigerant now, because the stuff they used to use in refrigerators, if it leaks, could potentially damage the ozone. And apparently that's worked, because the latest I've seen on this is that the ozone hole has shrunk and is continuing to shrink. So maybe that was the right thing to do. But it's not something I've dug into too much. But I do know that there's evidence that it's shrinking. And we like ozone because it protects us from ultraviolet light from the sun, which is damaging to your eyes and to your skin. It can give you cancer and things like that. So ozone's a good thing.
Would you attribute long ages in the Bible to that magnetic field being greater?
Good question.
More towards creation, or is that because God said so?
I think it's neither. I think, well, everything in a sense is because God said so. But the question is the mechanism. And for a long time, people thought it was environmental, something like that. But we now think that the better explanation is a genetic bottleneck, because it happened very suddenly, whereas the magnetic, although we do think the magnetic field flipped at the time of the flood, but then it gradually decayed after that. We think it's a genetic bottleneck. And basically, that's the founder effect. It's basically when you reduce the population to very few individuals, you're stuck with whatever genetic traits they have. So let's suppose, we don't have any information on Mrs. Noah other than she existed, because Shem, Ham, and Japheth did. But let's suppose that she had a gene for short-livedness, which she may have. Her age is not recorded. If that's the case, then potentially Shem, Ham, and Japheth, and every human being is descended from them, would also have a gene for short-livedness, you see. And so that's an example of this bottleneck effect. And the interesting thing, too, is Noah lived the full lifespan, even though a third of his life was after the flood. So his life doesn't seem to have shortened. He lived like 950 years. So whatever happened didn't affect him. That makes us think it's probably a genetic effect that can be traced to Mrs. Noah. The way the ages taper, too, they follow a mathematical relationship, which is yet further evidence that the Bible really is historically accurate, because we didn't know about exponential decays until relatively recently in terms of math. Very good. Any others?
Final one.
Okay.
For me, back to the Big Bang. I don't believe it either, but if an object is going to stay at whatever rate of travel or state it's in unless an external force acts on it, and you have a stable space, matter, energy at this point, and if everything is there, what's the external force that starts the Big Bang?
It's a good question. I'm trying to think how a secularist might answer that. I don't think most of them have a good explanation for what caused the Big Bang. Most of them accept it as an axiom. It's just as far as back as we can go scientifically, I think they would say. Yeah, I'm not sure how they would answer that, to be honest. I'm trying to be fair to them. I don't know how they would answer that. I know that some of them would say it came from another universe. There's some that say that a quantum fluctuation in another universe produced ours, and perhaps ours is producing other universes. Of course, there's no evidence for that. There can't be scientifically, because scientifically you can't analyze another universe. Because if we could analyze it, it wouldn't be another universe, right? We'd have to be able to access it, observe it in some fashion. But that would be one answer they might give. They would argue that the net energy is probably zero, because expansion is sort of like a negative. Well, gravity pulling things back is like a negative energy. Expansion is a positive energy. They would say the total energy is zero, so it doesn't violate any conservation laws. I think they would say that. I don't think it's a very good answer, but I think that's what they would say. Okay, any others?